Hi, I'm Shrikant. I'm working as a data scientist. I'm super excited to bring this course to you where this course involves multiple technologies to bring a machine learning based image classification website to life. This is the website you're going to develop and deploy in the cloud from scratch. Where you can upload the image. As soon as you upload the image, in the backend there is a machine learning model which predicts the image and display is what is the image and also give the probability for other categories too. Cool, right? To build this website there are several stages. SKImage for image processing, machine learning to develop image classification model, Flask to build the website, deploy to run the website in the cloud. Let's see one by one. Scikit image. SKImage is easy and most powerful image processing library in Python. We will teach you how to process the image in SKImage like conversions, histograms, and image transformations. Then we will start the project of image classification with data pre-processing. Here you will learn how to do the data pre-processing, labeling, feature extraction with SKImage and Python. After data pre-processing, we will send the data to machine learning model. We will teach you how to develop and select the machine learning model and tune it for the best results. Then we will do the pipelining our model for production. Now we will start building our website using HTML, Bootstrap for styling the website, and Jinja 2 template engine for dynamic data processing in Flask. With this stage, we are ready with our website and now we will deploy it in the cloud. Here we will go to the Python Anywhere, which is fast and powerful cloud for deploying the Python-based websites into production. We will show you how to deploy by doing the necessary installations in Python Anywhere Cloud and run the website successfully. Awesome, right? So what are you waiting for? Let's get our hands dirty and get into the course. Hello everyone, welcome back. In this lecture, we will talk about the image and pixels. If you consider any image and zoom the portion whatever we have shown here, and if you look in that image, this is how the image looks like. There you can see that there are certain kind of square boxes is what you can see here. This square boxes is called values or pixels. Each and every value is defined a color. So let's try to understand what is the values and what is the range of values. The range of values for a grayscale image is in the range of 0 to 2 to the power of n minus 1. For an 8-bit image, the grayscale image is in the range of 0 to 2 to the power of n minus 1, which is 2 to the power of 8 is 256, minus 1 is 255. So the range of values will be 0 to 255. 0 is basically the black color and 255 is white in color. Here I shown you that for the different values or what is the color that is being associated, particularly for the grayscale image. Grayscale means black and white image. 0 is black, 255 is white in color, and in between that you can see that intensity of the gray color. We can also define the values for the color. For the values for the color is almost same, just like the grayscale. It is from 0 to 255 for an 8-bit image. But in the color image, it's basically combination of 3 images. If you consider this image, which is a width of 5 and height is equal to 10, so we have the 3 different matrices will be there, or you can say the 3 different images are there. One matrix consists of information about the red color, and second matrix consists of information about the green color, and third matrix consists of the information about the blue color. If you combine these three matrices, and what you'll get is that you'll get some image something like this. Okay, and again, for the given saturation, for given one particular saturation, and the lower the value for 0, it is black in color, and the higher the value, it is what are the respective color for the each and every image. So higher the value for the red is 250, it's like no red, pure red, and pure green, and the pure blue. Define the better way of defining the color image is with a HSV. H stands for hue, V stands for value, S stands for saturation. So all the values is the range of 0 to 25. Let us consider the hue here. Hue will basically define the color here. The range of hue is between 0 to 360 degrees. 0 degrees is basically the red color. 120 degrees is green color. 250 240 degrees is basically the blue color. So what are the hue or what are the angle you want to set? It will define that particular color, and this is for one particular saturation. And the value is what this value in the range of 0 to 255. Lower the value, it is a dark, and higher the value, which is what are the color is this. And saturation is basically the key here. Lower the saturation, and what you'll get is that it will get the intensity of the color is being defined by the saturation. Could be the white or could be the original color. Lower the saturation, you will get like in a white, and up and higher the saturation, you will get the original color. So if we combine all three values, and what you'll get, like we can have the different sorts of colors will be there. So this is what the meaning of the pixel. In the next lecture, we will see how to load an image in a scikit-learn, and we'll try to split the image into three parts: red, green, and blue. And based on that, we can understand the how the pixels is being created, or what is the red matrix, green matrix, and blue matrix. Thank you very much. Hey everyone, welcome back. In this lecture, we will talk about how to read image in skimage. So make sure you only download the images which was there in the resources, and this and all the images that was have been downloaded. So what we will do now is that we'll try to read an images in skimage. All right, let's open the Jupyter notebook. And now what we will do is that let's import the necessary libraries to read image. So for that, let's import the NumPy, which is a dependency library, and we'll also import skimage.io, and we also import matplotlib.pyplot as plt, and %matplotlib.inline. All right, sorry, space inline. All right, so we have imported all the necessary libraries. So what we will do, let's read an image, and you can see that I'm having the images in the images folder, and let's try to read an image astronaut. Okay, so in order to read an astronaut image, what we will do, let me take an img, and we can use skimage.io. So skimage.io .imread, and what we can do here is that it will ask for the file name, and you can also read it as a grayscale is equal to false. If you mention grayscale is equal to true, it will read in the grayscale. But anyway, I just want to read an image with the file name. What are the file name it is? So my image was in the image folder, and it was the astronaut.jpg. Execute it, and now you can see that. Let me print the image here, and you can see this is what the image that I'm having with me, and it is a 3-dimension array, and that's what we can see. It's a 3rd dimension array. We have R, G, and B. This is R, and this is G, and this is B, and this and all the what are the values we have. This and all the values which defines the color. Basically this defines the red color, green color, and blue color, and this defines the intensity of the color. 148 is probably like light, like it's a combination of black and red color, something like this, because it's not pure red, it's not pure black, it's a combination of that. All right, so let's see how to display the image. In order to display this image, we can use we can use plt.mshow, and what we can do is that just pass the array of it. Okay, and you can simply pass the array of that. So you can see that there is a x is there. What we need to do is that we need to simply pass the array. So it is array is img. So done. And you can see that this is what an image what we have is that, and which has nearly 500 rows and 500 columns. And you can also look into the shape of that image. It is img dot shape, and which basically says that it is 512 rows and 512 columns, and we have the 3 depth is equal to 3. Basically it is a third dimension array, and nothing but we have the 3 matrices, and which is basically having the 512 rows and 512 columns, and we have the 3 r we have the 3 matrices, red, green and blue. So that's what we can read an image and we can display that image, and this is how it's going to be looks like for us. We'll continue on the next lecture. We'll continue in the next lecture on more about skimage. Thank you very much. Hey everyone, welcome back. In the previous lecture we have seen how to read an image, and this is what the image we have. And what I will do now is that I'll try to read one more image of color wheel, and let's see what we can do with that color wheel. So let me take, this is my img1, and I can read an image skimage.io, which basically stands for input output, and imread. And what we can do is that we can pass the image path of that. It was the images, and color wheel is what the name of the image I want to do here. And now we can use plt.imshow img1. Here you go. This is what we have. This is the color wheel. We have different colors, red, green and blue. And as I said, each and every image, color image consists of the 3 matrices. You can see this color wheel consists of 370 rows and 371 columns, and the width and the depth is equal to 3. Basically it is the 3 matrices, red matrix, green matrix and the blue matrix. Red matrix basically consists the information about the red color, green matrix consists the information about the blue color, green color, and the blue matrix consists the information about the blue color. So let's see, for this image, let's try to split the array into 3 parts, and let's visualize that how exactly we can able to do that. Right, so what we're going to do now is that let me take R red matrix, which is basically img1, and I can do the slicing operation, colon comma colon comma. I just want all rows, all columns, and taking the R is equal to some 0, index is equal to 0, which is the depth is equal to 0, which is what my red array means. This is the red matrix. Basically this consists of the information about the red matrix or red array. And similarly, let's take the G is equal to img1, and which is colon comma, this is 1, this is my green. And similarly blue is equal to img1 colon comma, this is my 2, and which is my blue, RGB. That's why this matrix is called RGB. Let's execute it, and what we can see, you can display you can print the R. As soon as you can print the R, what we can see, looks like some 2-dimension array, and you can look into the shape of that. It says 370 comma 371. Basically take all rows and all columns, the depth is equal to 1, and this is what the the matrix of the red color, okay, consists of the red color information. So let's try to visualize it. plt dot mshow, I can visualize as R, and here you go. This is what you can see, that this array, red array, consists of information about the red color. Where is the red? This is what the red. So that's what it highlights, the red portion. Basically any 2-dimension array is a grayscale image, so the better visualization of that could be convert that into gray. Now you can see that this is about the gray. So lower the value, which is a black, lower the value is black, and higher the value is white. So we can understand that what this says is that this color, what the how larger the value we have, the white in color region is basically the 255. So here is where what the most of the red information is there. That's what we can see here also. This is what, like, most of the red information is there in this region. Okay, and let's also plot the green. Plt dot show of green and cmap equal to gray, and similarly also plot show b cmap is equal to gray. So we have, like, three matrices, and what I'll do, I'll just use the subplot and I plot it. Plt dot subplot, and it is 1 comma 1 row 3 columns and 1, and copy, paste it and paste it, and this is the 2 and this is the 3. And what I can do is that, like, plt dot m figure and fixed size, which is let's say 10 comma 6 is the what, like, the figure size. Here you go. Now we can see that, like, this consists of the red, and this consists of the green, and this consists of the blue. That's what information about the blue is there in this. So if we combine all the three, you will get this. So that's what we can see. Let me also plot that. Plt dot show and plt dot m show again will take the img1 is what the plt dot m show. So here you go. What you can see is that this is what the original matrix, and we splitted the matrix into three parts, and this is the red, green, and blue. If you combine all together, if you combine all together, or if you embed all together, basically you will get the color image. That's what, like, the RGB image is this. So any image is consist of this three portions: red, green, and blue. All right, so we can also, for better understanding, we can also color this. Instead of doing that, I can also basically, I can color that. Instead of making the cmap is equal to gray, matplotlib will give you lots and lots of things. I can convert that into reds, I can convert that into greens, just for the better visualizations. I can convert that into blues, and let's see. Okay, this is really cool. Now we can see that this is the red portion, this is the green portion, and this is the blue portion. If we combine all together, we will get basically this. All right, so this is about, like, the RGB and the pixels. So in the next lecture, what we will do, we'll talk more about the SK image. Thank you very much. Hello everyone, welcome back. In the previous lecture, we have seen we took an image and we split the matter images into three parts: red, green, and blue. It says, like, information about the red region, information about the green color, information about the blue. So, and what the idea behind that, having the red, green, and blue, having the almost having the information about the image. And instead of working with the three images, and if at all, if you have a chance of converting that into one image, that will be really great, right? And such kind of image is called grayscale. So now let's see how to convert that image into grayscale using the scikit image. Okay, so for that, what we need to do is that I just want to import a library. So from skimage dot colors. So this is what a library I just want to import now. Now what I can do here is that, as I can see, I have already imported the couple of images. One is the image one. This is what the image one, and also imported this. So what I'll do, I'll take this image img, and let's see, let plt dot mshow img, and this is what the color image I'm having with me. And I will show you, like, how you convert that color image into grayscale, so using scikit image. So it's very simple, it's a pretty straightforward working with the scikit image. And what you need to do is that gray is equal to skimage dot color dot, and there you can see, like, there are a bunch of conversions what we can do here. And here I just want to do is that, like, we need to convert that RGB to gray. So this is what basically I just want to do now. I just want to convert that image into RGB to gray. Let's take this now. Here you go, it's asking for the RGB image. So this is what the RGB image, and I'll just pass it to the RGB image to it, img. All right, execute it. So that's it. So now we have successfully converted that RGB into a grayscale. Let's visualize this now. So for that, plt dot imshow gray, and that's it. So this is how, like, you see, any two-dimension array is a grayscale. You can look into the gray here, and we got some kind of some values, and all the values between the 0 to 1. Any two-dimension array is a grayscale image. And previously, the array, the image shape of the image could be that it is image dot shape, and that is 512 by 512 by 3. I just converted into this grayscale. So what this means, basically it will combine all the three information. It'll combine the red information, it'll combine the green information, it also combine the blue information, and you'll get that. Okay, so for the better visualization, what I'll do, I can take the cmap is equal to gray, and here you go. This is how you can see, how can I able to convert that any color image into grayscale. You can even save that using the scikit image. So skimage dot input io dot im save. You can save that image. Just specify what is the file name you want to save. In here I just want to save in the images folder, and let's say astronaut dot, let's say this is a gray. Okay, astro underscore gray dot jpg. Whatever the format you want, you can simply save that, execute it. And of course we need to pass one argument. This is the file name, and which array I just want to save here. This is what the array I just want to save here, and copy and paste it here. Now you can save that. Okay, done. Now you can say that it is being successfully saved. It just gives you a warning that because all the values which was there in the 0 to 1, and for the better conversion, what it is doing is that it is going to convert that into integers and being saving that to you. So that's what it is doing now. And of course you can go to your folder, and you can check that and see this is what the color image, and this is what my grayscale image. Perfect, right? Excellent way of conversion of the color to grayscale. Okay, so this is for how we can convert that any image into the grayscale. In the next lecture we'll talk skimage. Thank you very much. Hey everyone, welcome back. In this lecture we will talk about image histogram. So what I'll do, I'll construct one image called landscape, and for this image let's try to understand the image histogram for that. So this is what the image I'm just want to work on now, and it looks like a pretty dim image. So what I'll do is that I'll work on the image histogram and try to increase the intensity of the image using the scikit image. Okay, so for that what I'll do, let's read an image. So img4 is basically, or img3 or 4 is basically equal is skimage.io dot read image. Basically what I'm trying to do here is that I just want to mread, and if we look into that mread of that and just read the image here, these images, and that one is landscape.jpg. Execute it. Now remember that actually the image whatever is given to me is basically the this image is basically the RGB. It's a color, it's a grayscale. This image is basically a grayscale image, but when I'm reading this grayscale image, I'm getting some RGB image. So by default this image will read in RGB. So we can specify that which image you read that image as a gray. Okay, what we can do is that you can ask that image to read that in gray. So either you can convert that into RGB to gray, or you can also read that image start away as gray. So I can mention as gray is equal to true. Now you can see that this is what the image for, and which is what my RGB. So this is the grayscale image. Okay, but the problem here is that all the values in the grayscale is between 0 to 1. Okay, all the values is between 0 to 1. So 0 is basically the dark color, and one is basically the light color or white in color. You can also look into the in plt.enshow and make sure cmap equal to gray, and you can specify that, and now you can see that this is what the image we are looking now. It's very pretty dark and dull, and let's look into the histogram for this. And in order to get the histogram for any image, what we need to do is that the step one, you need to flatten it. So you can flatten it by using the retravel and use this flatten image. This is what the just a flattened image. It's simply it is the number of rows into number of columns. The length of this is number of rows into number of columns. So that's what we got. Now with this we can simply plot the histogram, and remember the number of bins that we require is 255 variations. Basically we will have the image for particularly for 8-bit image, we will have the 255 variations. So that's the reason what we will do is that the number of bins for this is 255. Now plt dot show, I'm sorry, this is the histogram or hist, and what is the image, what is the value of r? I just want to give is flatten image, and bins equal to 255. So and plt.show, that's it. That's what you can do is that you can get the histogram of this. So now you can see this is how you can plot the histogram of that. What you can understand here is that all the values whatever we have is between 0.45 to 0.8. so since all the values is between the 0.45 to 0.8, and that's the reason what we have is some or mostly some dark. Most of the values you can see there are mostly the dark, and very few values is being white in color. We can also find there is no pure dark and not pure white. Okay, so and this is what good understanding about the image, what is the how the image is, and it's a really very good way to understand the image dynamics. And the next lecture what we'll do is that we will use the histogram equalization, and with the help of histogram equalization we will see how to increase the intensity of the image so that it looks much more clear, the image might looks much more clear. Okay, we'll see in the next lecture on the histogram equalization. Thank you very much. Hello everyone, welcome back. In this lecture what we will do is that we'll try to work on the histogram equalization. So histogram equalization is a technique. What we'll try to do is that instead of the putting the values in a specific range like 0.45 to 0.8, what it will do is that it will spread the our bins. It already spread our colors, so that if you able to spread our colors, so that we can see that a nice view of each and every pixels, and with that case our image will get brighter. Okay, now let's see how to do the histogram equalization with skimage. So import skimage dot exposures, and I just want to import histogram equalizer, HIST, from, I think this is not import from, what I want to do is that I just want to import equalize histogram. Okay, now this is what is enough, and what we will do is that we'll take this functionality equalize histogram, and what I want to do here is that I just want to specify the image, and the number of bins is 256. Of course, by default 0. Now it's 0 to 255 basically. Of course the number of bins that we basically required is 256. Okay, let's keep it as it is. Now what is the image? Is image 4 is the image 4 is basically you're looking for, which is what my grayscale image, and the number of bins is 256. I just leave it as it is, and this is what my equalize image. Execute it. Now what we can do here is that let me print plt.mshow equalize image, and change the color map to gray. Here you go. Now we can see that, like, nice view of the image. Now the image is gets a little bit brighter. Now we can clearly able to see that, like, how the image is, whereas here the image is not that clear, but here we just make it like, image is much more clear and easy to understand. So this histogram equalization is a very, very useful technique when the image is dim as dark. Then histogram equalization is a really useful technique to make it brighter. Okay, so, and of course we can also save that image. For that, what we will do is that skimage.io.imsave, and what is the array just want to save is histogram equalize, and what is the name of the array just want to save is that, like, landscape hist eq.jpg. Okay, I think, okay, do that. Oh, this is the image should be here, and here probably I'll just save it in the images folder, and this done. So now we have successfully saved our image. So let's open it and see. Now we can see that this is what the landscape image, and this is what the brighter version of this landscape image. This is really good, right? Compared to the some dull and not that not that well visualized. And this is a really good way to visualize. Now we can see, like, how what are the slides are there and etc. Everything I can clearly visualize rather than this dull image or dim image. So this is what the one of the application of the histogram equalization has been used widely if at all our image is dim. Thank you very much. We will continue in the next lecture. Hey everyone, welcome back. In this lecture, we'll talk about how to resize an image. Resizing the image is very, very useful technique. So now let's see how to resize an image. So what I'll do now is that let me go to this image copy.jpg, and let's open that and look at the size of that. So for that, image underscore 5 is equal to skimage.io and mread. What I'll do is that let me read that images, it is my copy.jpg, and you can also this is look into the size shape of the image, and which is having the 400 rows and 600 columns into 3. Okay, and what we can do now is that we can simply resize the image, and let's visualize the image first. The plt.imshow and image underscore 5, this is what the image, and the one resizing the image is basically reducing the shape of the image or reducing the size of the image to smaller, or you can also increase to larger size also. So for that, scikit image has a very cool version called transform. So for that, what we will do is that from import skimage.transform, what we'll do, we'll just import skimage.transform. Now let's see how to resize the image now. So for that, let's take the image, let's say image r, and that's going to equal to skimage.transform.resize. You can use this resize, and what are the size you want, you can really resize the image. Now what I'll do, let me take that image file, and what are the output shape you want, you can specify the output shape. The output shape I just want here is let's say I just want to do the 50% because it's a 400, so 200 300 3. That's for the size. I just want to resize now, and now let's look into the image underscore r dot shape. It's got in that particular shape. So what are the shape you want, what are the size you want, you can simply resize it. So let's look into that plt dot imshow image underscore r. Now you can see that we reduce this size from 400 to 600 into 200 by 300. We can even increase the size of the image. Let's say this is r1. I can even increase the size of the image, let's say 400 to 800, 600 to 1200. Even that is also possible with the scikit image. So this time I increase the image, I double the increase size of the image. Now you can see that img underscore r1 dot shape. Here we go. We have increased the size and look into the shape, look into the image, plt.mshow img underscore r1. So that's it. So it looks almost same. And this is what 800 by, this time it is 800 by 1200. So this is how you can transform the image into what are the shape you want. So this is about the introduction to scikit-image for the project perspective. In the next lecture, we will start the project. Thank you very much. Hey everyone, welcome to data preparation. The task of this module is to do the image classification. For doing the image classification, the first step what we need to do is that we need to do the data preparation. And the steps that you need to perform for the data preparation is understand the images, size, create collection, label, and finally save what are the data you have been prepared in the pickle format. So these are all the steps that we are going to do in this course here. The first is understanding the images. So in understanding images, we are trying to understand how many types of classes and what are the size of the image and the shape is there. And after that, we will read all the images in an array and save it in a list. And then we will also do the labeling for each and every image. Means depends upon the class, we will mention that what kind of class it is. Finally, we will save that entire data in the pickle. So the data that whatever we are dealing here is this. So the data what we have is nearly there are 2000 images are there and 20 classes is what we are going to deal here. So we are having the 20 different classes in the sense we have the head of bear, cat, chicken, cow, human hair, lion, monkey, mouse, and natural, and so on. So these are the 20 different classes of images that was there with us. So what we are going to do now is that we are trying to build the image classification model, and that image classification model will able to detect or will able to predict that what kind of head it is. It is either a human head, eagle, elephant, or so on. So that's what basically we are trying to do in this case. In the next step, we'll see how to do the data preparation in Python. Thank you very much. Hello and welcome back. So now let's look into the data and understand it. So hope you have downloaded the data, and in the data you have 20 folders here. So these are all the folders: bear head, cat head, chicken head, cow head, deer, dog, and so on. And inside that you can see the images of all the bears. So this and all the images of all the bears that was having, and similarly for images for the all the cats, cat head, and images for the human head, and so on. So like this, what we are having is that we are having like 20 different folders, and each and every folder that represents the class. For example, this is the class bear, this is the class cat, class chicken, and so on. So this is what the data we have, and what we will do is that we will try to load that. And before that, also let's look into the properties of the images. And one thing you have noticed that all the images that are given to you all are in the JPG format. So let's right click and let's look into the properties of the image. And if you look into the properties of the image and click on the details, and there you can see the width is 80 pixels and height is 80 pixels. So all the images whatever are given to you all are 80 by 80 images. Means the data whatever we have is all are 80 by 80 pixels. So it was partially pre-processed, means all the data they collected the data and did already the partially pre-processed data. So as you can see, all the images whatever we have is that it is 80, width is 80, and height is 80. So that's it. So that's what the data whatever we had with me. So in the next step, we'll see how to load the data, how to load all the images, and also we also look into some data preparation methods for those images, for these images in Python. All right, so we'll continue in the next lecture. Thank you very much. Welcome back. Now what we will do, let's load all of the data we had and load all the data in Python. So first open your Jupyter Notebook. In order to open the Jupyter Notebook, open your unconditional prompt and copy the path, or whatever the path you are working on, and set the path, and just now set the path and go to that particular directory and tap Jupyter Notebook. So in this case, my Jupyter Notebook will get open. All right, so let me maximize it, and this is what the Jupyter Notebook I'm having with me, and all the files that was there, like bar head, cat head, chicken head, and so on. So this and all, each and remember, each and every folder is one class, and inside that there are so many images of it. So we need to read each and every image, and we need to get understanding on this. Okay, the first step what we will do is that just load the Python, and after that we will import the necessary libraries that we are going to use in the data preparation. The first step is that, data preparation. Let's import all the necessary libraries. The first one, we will import NumPy, SNP, import pandas as PD, import matplotlib for visualizations, matplotlib.pyplot, splt, and also let's import scikit-learn from sklearn, import sklearn, also import skimage.io, also will import skimage.features, also import skimage.transform, feature and transform. Okay, so all next what we have to do is that it also import we'll also import OS, and just to understand what are the directories that was there. And the next what we will do, we'll also import from glob, import glob to get all the pictures. Just import glob from glob, import glob. So and this is what basically I use to extract the images. This is basically particularly I use to extract the path of the images. For that I use this glob. All right, and so we have OS, and we also import the regular expressions array, because I need to do some kind of text pre-processing. For that I will use the regular expressions. And finally what I'll do is that matplotlib inline. So that's it. So this and all the libraries that I'm going to use now, and if at all I'm going to add any few more libraries, and what I will do is that I will add here. So the first step what I'm going to do is that just look into my data. So this is what the data I'm having with me, and this and all the folders are there. So what I'll do is that first let extract all the folders. So just read all the folders in list. Okay, I just want to store all the folders in the list. Okay, so the first thing, the folders we can take os.list, os.list directory, list dir, and inside what is the path you want, and inside that what are the files or what are the name of the direct file you want to know, you can simply do that. So but here what is that my directory name is that data. So inside that data directory, so if at all I want to know what are the folders, I can simply use this. So let me print all the folders in a list. Yes, that's it. Now what you can see here, I get all the folder names: bear, cat, chicken, cow, deer. So all the folder names that I can able to extract here. All right, so the next step what I will do is that I will basically extract the images path, like and where what are the images are there, and or the name of the images, because in data in where you can see there are almost so many images are there. I just want to know the path of the images, so this is what the image name. So what I'll do now, I'll try to extract this. So for that I can able to use this glob here. So glob, and the how to do this glob is that we need to give the path name. So it was in the data, it was my data directory, and after that we have like bear head, cat head, and so on, so many things out there. So I can able to do the dynamically, I can able to pass the folder name, since I already has the folder here, and I already know that like all the images what I'm having is that, or having extension of .jpg. So I use a regular expression command star.jpg. So this star will able to fill that gap here. What are the names you have, it will able to fill the gaps, and this is what I'll just pass it here. So for example, format, and inside the format, let's say if at all I want the what are the file names that was there in the bear head, and I can get this. All right, so I can get all the list of file names in a list. So what I'll do now is that I will run this in a loop, for loop. So for folder, or let's say f and folder, so this is what the folder. Now what I'll do, I can directly dynamically give the values, and this is my f. So I'm just passing my f, and I can simply do one more thing, like I can create an empty list. Let's say this is what my all paths, and I can simply do this, and this is my all path. What is this? This is what basically my all path. Oh, sorry, I can I'm getting all the values here, so which is equal to, and I can add. What I'm doing here is that I'm just trying to append each and every values in all path. So that's it. So this is how I can simply make the all the path values and also all the images. Right, so this is a very simple thing. This is how I can very easily I can make each and every values that was there in the list. And the next step, what I want to do here is that I need to do the labeling here. Okay, what I want to do here is that I just want to do the labeling. So how to do the labeling? So that's it. So this is how we can able to get all the images and the list path directory in all path directory. This is how I can, that's it. This is how I can able to get the image names and also respective path and the list. In the next step, what we will do is that we will see how to do the labeling for each and every image. Thank you very much. Hey guys, welcome back. Now what we will do is that in the previous lecture we have already get the path of each and every image. So what we will do in this lecture, what we will do in this lecture is that we will see how to read all the images, and also we will look into the labeling part. So the read all images and labeling. So we have already imported the scikit-learn.io. So I'll make it um, we have already imported scikit-image.io. So I'll make use of the scikimage.io. So image underscore all, so which consists of all the images, and skimage.io, and there is image collection is there, and image collection will read all images at once. So what I'll do, I'll copy this path and I'll just give it to you. So this, it will read all the images in an array, and that is going to be stored in the image underscore all. So that's it, perfect, right? So this is how it will do. So done. So now you can see that it can able to read all the images. Now if at all you look into the length of all the images, we are having 2057 images are there, so it can able to read all the images of 2057 images. Perfect. So this is how, guys, we can able to read all the images. And also we can see, like, image underscore all, and there is a files is there. Obviously this files is actually consist of this information, but so there could be some missing information could also be there. So what I'll use is that I'm going to be use this information to extract the labeling here. So this are all the files, and this in this order all the images has been stored. So what I'll do is that I'll take these files, and in this case, remember, bare head is what the class name, that's what I need to take here. All right, so what I'll do now is that let's write one function, regular expression function, that will able to take out this like the bare head and so on. And if you look into this, there is a pattern here. The first thing, it is followed by data, and after that double backslash add, double backslash, and followed by the image name is there. So image name might varies, and but the data still remains constant, and the double backslash is also remains constant. So what I will do now is that I'll use the regular expression search to find out this pattern here. So now let's do the labeling. The first step, what we will do is that we will extract the text, or we'll extract the folder name. The respective folder name is what I just want to extract here. So for that, I can use a regular expressions command and array.search. And what I want to search here, you can see there is a pattern. It looks for R stands for regular expression, and the pattern I was looking for is that dot forward slash data, and this is here. I just want to look something here, and anything here. So what I'll do, anything, either single or double or whatever. So I'll take anything letters and the regular expressions, and followed by back forward, like to the backslash slash. So what it'll do is that it'll search for the data. This is what the pattern, and whatever the things it is being inside that, it will extract it between this up to this. So up to here. So from here, and from okay, or this text to this text, what other text is being there, that is what going to be extract by this. So what we will do, so that's what I'm having with me, and the string that, let's take some sample string. This is what the sample string I just want to use, and after that, let's say it will get the values in the group, and let's take the group one, and perfect, you got the bare head here is what my group had. So this is what we can do, and we will write a function, and what we will do is that we will try to write the function here. All right, or else we can do one more thing, that since head is also common, so I don't want to get the head and just remove all the head, and if at all I want to remove all the head, then straight away I can say, this is the head, and double backslash, I can get only the sorry, just put the comment here, so I can get only the bare here. All right, so this is how we can get, and this is my text. So let me write in a function, and this is the function that to extract all the labels, extract labels, and if you pass the text here, or what are the path, and that it will take that particular path, and that's going to be written here, and this is what the text, and this is going to return the label. That's it. This is going to return the label, whether it is what are the label it is. So what we will do, we will return this label in the lowercase. That's it. This is how I can able to get all the labels here. So this is what my image files, and let's map all the image files into it. So let's do this map, and the function is extract label, and this is what my all the paths that was there, and labels equal to list of this. That's it. This is how we can get, oh, we got an error. Okay, why we got an error? Let's try, and because that's some text may not be there. So what we will do, let's print the text here. So what happened to the text? For which text I'm getting error, I can check that. Okay, this is all fine, and yeah, for natural it is been there. Okay, so then I can't use this. Then what I can do is that just remove the head, because for natural that is not there. So I can do simply one thing. I can do this try here, and I'll do this label this. If I'm getting error, then what I'll do, I'll try one more. This is the label. So this is what I'm going to try label. Instead of that, I'll just remove the head of this. So both are same, so I can do this with that. All right, so oh, this is accept. Now execute. Perfect. Now we got all the labels that was there. So let me get the length of all the labels, and there are 2057 labels out there. Got it? So this is the 2057 all images, and 2057 labels has been there. So that's it. This is how we can able to extract all the images and all the labels here. So that's it. This is how we can able to extract all the images and the labels. In the next lecture, we will see how to save all the images in the pickle format. Thank you very much. Hey guys, welcome back. In the previous lecture, we have seen how to label our data and also how to load all the images in the image all. So that's what we have seen in the previous lecture. So now what we're going to see is that we are going to store each and every values or each and everything in the pickle. So before that, let's try to do some basic analysis on some, let's not analysis, at least we'll look into what is our image and how our image looks like, etc. So let's do that. So you can see that there is an image all is there. So what I'm doing in this case is just taking and reading all the images. So image underscore all is there, and if it all, if you take this, the problem is that it is a class, and in order to get the image, what we need to go here is that we need to call with an index number 0. If I give the index number 0, what I'm getting is that this is what an image is, what I'll get. And this is a 0th image, and this is the first image, and this is my second image, and so on. So we have all the images that was there in the object. It was stored in an object. So what I want to do in this case is that I just want to bring all my data in an array. In order to do that, what we can do is that we can write a simple function, simple buffer function. So that's what I'm just taking the simple buffer input IO. Just take some input, or let's take some input output, simple buffer, and return output. That's it. So that simple buffer function is what I just want to write in this case. And now image underscore all underscore arrays. So this and all the images that is being stored in the variable img. So what I need to do here is that I need to create a map. Now apply the function buffer. So that's what I'm going to do, apply the function buffer, and the array that I'm going to give is that img all. So what it will do is that it will take each and every value and is being stored in the image array. So that's it. So that's what I'll do. So let's convert that into list. So that will get the list, and then we need to convert that into array. np.array, so which will actually do all the values for us. Execute it. It will take some time, so please be patient while it is being run. All right, it's done. So we have successfully loaded all the images in img underscore all underscore arrays. There you can see all the arrays has been stored, and you can look into the shape of that. What it sees is that now it is the 2057 arrays, and each and every array is 80 by 80, and 3 indicates is the depth of the image, or RGB. So that is how, like, you can able to read all the images. Okay, now what we can do is that let's do simple analysis on the what is the count of this and all. Okay, now what we will do is that let's save everything in the pickle. So let me create a dictionary called data, and this is my dictionary, and create a dictionary dict. And inside the dictionary, let me call some features. First one, I'll make it as let's say it's a description about the data as a text file. And what I can say it is I can write something like, there are 20 classes of 20 classes, and 2057 images are there. All the images are there. All the images are 80 by 80, and it's being stored in RGB format. So those kind of information, and whatever you want, you can write down here. So that's what the description. And second thing is the data, and my data is this. So this is all image underscore or underscore array is what my data. Okay, and the next step, what I want to save here is labels. Okay, or target. So this and all my targets or labels, and that's what I need to store here. And we already extracted all the labels here. Just take this and put it here. So that's it. So, and we have all the labels, and you have all the targets, and everything is being stored. And if at all you want to know the actually what is the labels are there, real labels are there, and you can take the Unicode of this. So what I mean to say is that you just take the Unicode of this. Since the labels, what are the labels you have, it was in the list, you can convert back into set to get only the unique list of elements. Okay, so like this you can create, like, whatever the dictionary you want, whatever the way you want to store, you can simply store it. So execute it. So that's it. This is how, like, we can able to execute our data. Now we can see the print, and this is the descriptor and data, and scroll down, look, a lot of things. And this is my labels or targets. Everything is being stored in the dictionary. It's a nice way of storing it. All right, so what I'll do now is that let me save the file and pickle. So pickle is generally one of the most convenient way of storing. So let's import pickle, and I can store the pickle. Also, let's import collections. Okay, so I'll just use a collection just for the analysis. So now what I'm going to do here is that let's store the values in pickle. So pickle dot, I just want to dump. So this is what I just want to do here, and I just want to dump an object. What is an object I want to store? The object I want to store is the data is an object I want to store here, and the comma, and the file name that I want to store here is so let me open the file first, and the name of the file I just want to create is data underscore animals underscore head. So all the heads are there, and just represents the 20 indicates the classes. So I can save it with the name as pickle. Okay, and the kind of mode I just want to save is write in bytes. That's it. So that's how you can save it, and it is already saved successfully. So just go back and go to your main folder. There you can see that my data has been stored. So in this, where all the values that is being stored here. So the data underscore animals underscore head dot pickle file is what I'm just stored now. And in this, I'm having all the data that is being saved in an array, and the targets and labels, everything is being given there. So this is how we can store our data. Alright, in the next lecture, we'll talk about some basic analysis on the labels, and also we'll work on the sizes. Hey guys, welcome back. In the previous lecture, we have seen how to save our data in the pickle format. Now what we will do, let's do some basic visualizations on the labels, which means like how many labels are there. Just look into some visualizations on labels, and also we'll look into our data, like we have never till now I have not shown the images. So we also let's plot our images and let's see how it is been. Right, so what I'm doing now, and let's already imported the collections is there, and making use of collections, and in collections there is a counter is there. So counter will basically count the count the list of values, like how many times that each and every value has been repeated, and that's what it is being to count here. So in this case I just want to count my labels. So if you look into that, and this is what my count labels, count values, and you can just print that count values, and that's it. Now we can see, oh, we have not saved many. Oh, this is not count labels. We need to look into the targets. Okay, I'm sorry. So now if you look into the targets, now there you can see, like bear, there are 101, cat 159, chicken 100, and so on. This and all the values, that is what we have stored. So let's draw some bar plot, so that will be really easy for us to visually. We can say, like which is highest, which is lowest. So for that, what I can do is that I can simply plot it. I can simply use this bar horizontal plot. Whatever you want, we can plot it, and the data that you need to give here is what are the data I want to give here is that you can remember that I'm getting the values in the dictionaries. So first, for that I need to split the data into my labels, or I can say this is what my x-axis or y-axis, what is my y-axis want it looks like. And my y-axis, basically I just want to draw the horizontal bar plot, so that's why I'm doing this. And in this case, bear, cat, and so on, this should be in my y-axis. So for that I can take like count values dot keys, which will basically gives you that. And also, if at all you want to get this all the values, take the values like this. Values is equal to count underscore values dot values. That's it. So this is how we can get this. Now there is a bar h, you have the y-axis is there. The y-axis is y underscore axis, and height is my values. That's it. Oh, this is not height in this case, this is the width. Okay, anyway, the width is my values. Oh, so dict keys is unhashable. All right, then, because this is in the dict keys, we can do one thing, you just convert back into list, so that it will be easy. All right, now this is really cool to understand. Let's plot it. Let's increase the figure size, plt dot figure, and fixed size. So let's increase the width to 10 and height to 6, so that it is at least a bigger one, and you can understand in a much better way. And let's name it as my x label. I can view the x label as um, this is the count. X label is count, and my title, plt dot title, and the title is counts, label count. Okay, that's what my title. And that's it. So this is finally pl.show. So we have everything has been there. Now what you can analyze is that here you can see the number of pictures in the cat is really high, and the distribution wise we have almost all are equal in size except natural we have very low images, even though less than 10. And the good amount of images what we have is cat, we have dog, and we have tiger, pigeon, panda, and so on, and the rest all are almost equal. Okay, so but more or less you can see, like, even 160 100, it's not much difference. It's also okay, fine, that's what we can able to understand in this case. And remember, you can give what are the color you want. If at all you don't like this a blue color, you can change what are the color you want, you can change that. So for that, what we can do is that you can specify color to red, and you can get the red color. Or you don't like this color, and go to Google and type the HTML color codes. What are the color code you want, you just pick the color. In my case, what I'll do, I'll just going to pick some color, probably this is I like this color. I'll take this color, and this is my hexa code, and copy this hexa code and I'll paste it. All right, so that's it. This is how, like, I can simply able to plot what are the color I want. Done. So, and the next step of what I'll do is that let's try to uh, plot our data. Let's try to plot our data. For example, in data we have all the images are there, and the shape of the images is this. So now what I'll do is that let me take one image. And this is what one image, and let me plot it. Let me visualize it. plt.mshow and plt.show. If I use this plt.show, and what I'm having is this nice plot, so I can really get some nice visualizations. So this is what I can get here. This is a bear, basically. This is what the bear, right? So I can remove this xtext with plt.xtext text is equal to this, and plt.ytext is this. So I can remove that. I can also apply to the title, plt.title, and what are the title you want, you can really give that. For example, it was in the data, and it was in my target 0. Okay, and that's a bear. So this is what the bear I'm having. So like this, what I'll do, I'll dynamically plot all the classes which was there with me. So let me create one. Since there are 20 classes out there, what I will do is that we can do whatever the way you want, you can create it. But what I will do is that I'll create the 7 by 3 or 3 by 7 is what size I'll create, and I'll plot it. Okay, so what I'm doing here is that 3 by 7. So for now, just take it like, what we want here is that let's dynamically generate it. Just remember that we need to dynamically create all the data. Okay, we need to dynamically create all the data. Since for dynamically creating all the data, let's take the data dot labels. So this is what the labels I'm having with me, and I need to dynamically create it here. So let's convert that now. What I'll do is that, like, this is what the data dot labels is there with me. Now I'll run a loop, something like this, um, for C stands for class, and data of labels, so which consists of all the labels is will be there. So let me comment this, so that I will plot I will just want to check everything, is this working or not. Okay, got it, good. Now you can see the first one's mouse, panda, and so on. That's what we got now. And the next thing what we need to do here, and the next thing what we need to do, we need to find out the position. We need to find out the position of our a label. For example, I just want to find out where my mouse is. For that, I can simply go to this label. Means I already have the targets is there with me, so there are a lot of targets is there. So I need to pick I need to pick the index position of that. For that, I'll take the index and index of C. Now just print this. What happens is that, like, it will give you the index positions of each and every C that you're going to return here. For example, here it says the index position of mouse is 1303. It gives the first index position. Basically, it is going to give the first index position. So now I got it, like, what is the index position I'm having with me. So this is what the index. And next I'll do is that, let's take the image, and from data of data, and call that particular index, and you'll get the image here. So that's it. So now what you do is that you need to plot it. You need to put it here dynamically. What you need to do is that you need to put that here, saying that, okay, this is what the image, and this is what the label. C is my label. See, that's the title. I need to put it into the title, something like this. Okay, so let's plot it. Now you can see this is the mouse, this is the panda, and wolf, eagle, elephant, dog, bear, sheep, and etc. So everything has been there. So let me use the subplots now so that I can automatically get that. So let me create 7x3 subplot. plt dot subplot 7x3 or 3x3 rows in 7 columns, and this, okay, I is what I need to dynamically generate that. So in order to generate that, I can use this I here, and I just need to enumerate it. Okay, I'll just enumerate so that I can dynamically get the index positions. And remember, subplots will never work for 0, so that's why I'll just add it with 1, and I can get all the values here. So, and the plt dot show should be at the outside. Now let's plot. Now let's see. So done. So we got a near good plot now. So what we will do, let's increase it. Let's increase the plot size. plt dot fig size. Let's change to some width is 12 and height is 6. All right, so this is really cool. Now we can see, like, this and all my images that was there: mouse, panda, wolf, eagle, chicken, elephant, dog, bear, sheep, natural. This is the natural and human, deer, rabbit, tiger, cow, monkey, and so on. So this and all the images. So this and all the images that was there with me, and this is what the data preparation. And in the next step, what we will look into, that we will look into the data pre-processing, where we are trying to understand few more steps that we need to build before passing that to the, or before training the machine learning model. Thank you very much. Hey everyone, welcome back. In the previous lecture, we have seen how to do the data preparations. In this module, we will look into the data pre-processing, like how to extract the features and converting into the grayscale, normalizations, etc. And also, we will also look into how to train the machine learning model. All right, so first thing what we need to do is that let's import all the necessary libraries that are required to build the model. So the first thing is that I need to import import OS, and also import import the regular expressions, even though that's not required, but it's a good practice to import all the necessary libraries. Import pickle, import numpy as np, import pandas as pd, import matplotlib.pyplot matplotlib.pyplot as plt. Next, import cbon, and import sklearn, and from sklearn dot pre-process. Okay, from sklearn we generally use this model selection. From sklearn dot model selection, import train test split, and from sklearn we import just import metrics. Okay, and what else you want? Okay, at the moment we have this, and if at all we have everything is comes while doing the operations, I will just import that. So that's what we need to do first thing. And remember, we also import the scikit image. So before doing this, importing the scikit image, I need to upgrade the scikit image. Hey guys, please try to everyone. I request everyone to upgrade the scikit image, please. So conda install -c conda forge and sk image. So we need to everyone actually need to I think it is scikit image. Okay, scikit image, everyone need to upgrade this because the version that actually I was using is a scikit. I think let me show you the version what I'm using once I upgrade this. Okay, since just install it because it's I already upgraded for me, so that's why it won't take much time. Otherwise, like you need to upgrade. I think this is not a good idea to update here. So what I'll do, I'll just stop these things because we will take a lot of time. So I'll stop this and open my Anaconda prompt. What I'll do is that I'll just open my Anaconda prompt, and this is what my Anaconda prompt. Now I will exactly type the following command: conda install -c conda forge scikit image scikit image. So it will take a while for you to install it. Just be patient while the installation is being completed. All right, now I got a message says that all packages has already installed because I already installed all the packages before doing this code. So I request everyone please type this command and install their scikit image. So this is what is the upgrade version of this. Anyway, so what I'll do is that let's import the scikit image. Let's import sk image, and also import sk image dot colors color, import sk image dot io, import sk image dot features, import sk image dot transform. So this and all actually the features that you need to do, that and all we need to import, execute it. Okay, okay, I got some runtime warning, no issue. So let's look into the version of that sk image underscore underscore version. And the current version that I was working on, it is 0.17.2. so make sure your version is more than this. So make sure whoever was working on this, so make sure your version is greater than 0.17.1. Otherwise you need to upgrade your scikit image, install it. In the next lecture, we'll talk more about the machine learning stuff. Thank you very much. Hey everyone, welcome back. Now let's load the data. So load the data. As we see in the previous module, we already downloaded we already saved our pickle data in the pickle format. So what we will do, we will load this pickle data. So I just what I will do, we'll just load that. So I think I already imported my pickle. Now take this data is equal to pickle dot load, and after that what you need to pass is the file name. So what are the file name you just want to load is just first you need to open, and the mode that you need to use is r_rb, read in bytes, and that's it. This is how you can able to load your data. Done. Now you can see all the files whatever we have been did, and everything is being there. Okay, so just give the description of this, what our data is. Just give the quick description of this. Oh, just take the description. Okay, the description is there's all the images are 80 by 80 by 3, and what we have is that we have 20 classes and 2557 images of that. So that's what my data is. All right, so what I'll do now, I'll just I just split the data into independent and dependent. That's it. Okay, so how to split the data? So let me take the capital X is what my independent. So data of data is what my independent means. This is what the input I just want to give the machine learning model. Of course I will do few more pre-processing so before passing into that. And y is what my labels. Okay, no, it's not labels, it's my targets. So y is basically the targets, and this is what my dependent. Okay, so just print just look into the, let's just print x, and this is what the x, and next is let's print y. So just print y. So actually there are so many things out there, just printing your y. Okay, so we have x and we have y is there. And the next step, what I want to do is that I just want to split the data into train and test. So for that I need to go for the train test split. So this is what the train test split that I'm going to use now, and I can simply take x train comma x test and y train comma y test, and that's equal to train test split of what I want to do in this case is that I just want to pass the values x comma y, and the test size basically I was interested is 20% the test size, and 20% is what my test size, and the stratify, I'll use a stratify sampling. Okay, and stratify is equal to 5. So that's it. So that's how I can able to convert each and every sampling techniques. Now you can look into the shape of that, and x underscore test dot shape. Okay, and y underscore train dot shape, and y underscore test dot shape. So I think this is just a length because it's a list, so maybe probably you will get only the length here, a y train of length because number of values, and this is also the length is what you are going to get in this case. Okay, so now what you can see here is that the shape is 6,000. There we are having 1645 images for the training, and 412 images that we are going to use for the testing purpose. So that's it. So we have we just set our what is the training and what is the test data. In the next lecture we'll talk about the data pre-processing, and which actually used for the pipelining our model. So we'll continue the next lecture on that. Thank you very much. Hey everyone, welcome back. In this lecture, we'll talk about the feature extraction. Feature extraction is one of the most important procedure whenever you're dealing with images. So without feature extraction, we really can't train the accurate models. So for more description about the feature extraction, particularly on the Hawk transformation, so I recommend to go to this website. It's really given you the nice documentation on how this Hawk feature descriptor is going to work on all. Hawk stands for histogram oriented gradients. Is really a good explanation on how it is going to be given and all. So it's a really good explanation. I recommend to go to this and look into that. In a short, I'm just going to be explain you what is the what actually it is. In short, what I'll just going to explain you on just a minute. Let me, yeah, let me check this. So this is what the URL that I want to give it to you. Yeah, so this is the URL. I'd like request to go to that. And in short, let's say if at all you want to consider one image, let's say this is what the line image I just want to consider. And here you just look into this line image. There are features in the sense each and every value or each and every pixel in the image is actually the feature. In order to know this is a lion, we really don't need to know, like, this the extra background information is really not required. Only the, like, the outlines, or just looking into the outlines, we can really able to identify what kind of image it is or what actually the classify it is. In the reality, we don't require the background. So the feature extraction, or also known as a dimensional reduction technique, hog histogram oriented gradients, what it will try to do is that it will calculate the gradients at each and every pixel, and using that, if at all the gradient is higher, and we'll take that particular information. Otherwise, if the gradient is low, means there is not much change in information. For example, here you'll get the lower gradient means a value near to zero, so that's why there is not much change. But when there is a change in color, here there will be the the gradients will be there. Means change in from a gradient in the sense partial derivative, the change in information is much more in that. So that's really help us to understand this. So in order to get more information about the histogram oriented gradients, I recommend to go to this URL and to read about this, how exactly they actually calculated this HOG, and how it will be really useful for the feature extraction. In short, what we will do, we'll take this image and we'll see how to do the hog transformation or hog gradients in the scikit image. So let's go back and please find the please find the date, please find this image in your resources. So just download that and go it. So first, what we will do is that let's do the basic feature extraction. Consider an image img, and in this image, what I'm trying to take is that I'm going to take this SK image from skimage.io. So let's read that image. .mread will read that image, and since that image was in my same directory, I can simply use this line.jpg. Now let's plot it plt.mshow of img, and we got this image. Now what is the features, what are the really the features that was in that. Let's actually make it big so that it will be easier. So this is figure, and let me use this height is equal to 6 and width is equal to 10. Let's make it figure size. Okay, now this is good. So this is what the figure, and this is size. And if at all, if I apply the hawk transform, what it will do is basically it will do the convolution operation. It will have the block, like, when block is there, and that block is tried over each and everything, so that will calculate the gradients. It's just similar to the convolution process. So that's convolution process we are actually doing here. So now what I'll do is that I'll take the hawk transformer, or I'll take this hawk transformer from the circuit image. Okay, so I'm having, like, SK from SK image dot features, which we already uh, from features. Just take this hawk. Okay, just take the hawk. It's a very simple, like, scikit image is really excellent library which will make your job very easy. Now what we are actually interested is all these things. So everything is being presetted, so you actually no need to do anything. So what we need to do is that we need to pass an image. Okay, we need to pass the image. What is an image? I just want to pass. I just need to pass that image. And the next thing is that I need to give the orientation. It is how many orientations you want, like, orientations in the sense it's the direction, how many there are a lot many directions out there, so how many important directions you really want to take it, that's the orientation. And I'll take the default orientation of 9. And we have, like, uh, pixels per cell. So this is actually the hyperparameter. We need to identify what actually the good thing. So, but we really don't know. Orientation is also, we need the hyperparameter. We really need to find out. Next is cells per block. So cells per block, we take this. So this is also one of the hyperparameter. By default it is a 3 by 3. I can take it like a 2 by 2, whatever, but this is the hyper, but this 3 are the hyperparameters that we need to do it. Okay. Oh, actually I can't apply this to the direct color image. What I need to do is that I need to actually convert that into the grayscale so that I can do that. So step number 1, basically I need to do the grayscale. So I can use a scikit image dot from sk image dot colors. I can do the RGB. Since my image is RGB, I can simply convert that into RGB to gray, and that's my image. So once I got this grayscale image, now I can able to do in this case. So just for the sake of visualizations, by default that we uh, by default the visualize is equal to false. So what you do is that you just make your visualizations is equal to true, so that you can able to visualize your hog image. So the first thing is it will return you the two things here. Basically it's going to be written, you can see it's basically it will try to return you the feature vectors. This is the feature vector is going to be returned first, and next is it's what, like, hog image. So the hog image is what I can able to see. Okay, so let's execute this. So it'll take some time because it's what it will try to do is it's trying to do in the convolution process. It will take some time. Oh, it's done. Now what you can see here is that feature vector, and this is the flattened image, and just look into the length of that. There are how many features it takes. It's almost 1 lakh 10260. Remember, the size of an image whatever we had is this. So dot shape will give you the size of this. So how many features are there? Probably if you take the grayscale, because we did the grayscale, so how many features you are having here, or how many values that we had is, like, 907 is to 645, and we almost had 5,85,014. So this many values are there. And what hawk transformer it tried to do, it tried to reduce that number of dimensions by 5 times in this case, according to the values whatever we used here, pixels per cell and the cells per block, according to this. And it's actually reduced the 5 times. So based upon the changing upon your operations, the values will get changed. So this is how, like, the hawk transformer can really helpful to uh, useful in the dimensional reduction process. Okay, let's visualize it. So first thing what I'll do is that let's visualize my grayscale image. The grayscale image is this. So let's visualize this grayscale image, blt dot imshow, and this is my grayscale image, and cmap is equal to gray. So let me use a subplot plt dot subplot, and I'll take like one row, two columns, and this is one, and one more subplot I'll take it. So this is what the two, and here I just want to visualize my hog image. So for the sake of the good visualizations, I will actually increase my figure size. And the figure size, what I'm trying to do is that I'm just taking the width is 12 and height is equal to 10, so that you'll get the clean good visualizations. Okay, cool. Now you can see that my data. Now there you can see uh, actually what you can able to see in this case is that the hog image. Okay, probably maybe you can actually look into that, how exactly that, like this is what the original image hog transformer, what it says is that, like this and all features are really really not important, but it looks into certain features where actually there is a change in gradients. That's what it looks. Now you can look into the shape of the line. Probably you can look into that. Probably I'll just if at all you can look into the line. What happens is that it's like able to um, the shape of the line you can able to see. So probably in order to have a clear view on this, I can reduce this. I can rescale this image size. So let's rescale this image size, and you can look into that. So I am already having this let's say image rescale. So let's rescale this from sk image dot transform dot rescale. Now I can rescale my original image. This is my original image, and the scale I just want to reduce by 1/3 is what the scale I just want to do. Now let's see how. So it's what I'm doing here is just rescaling and feature engineering. So I think we need to give the this image. So now let's execute it. Okay. Okay, image underscore search. Let's check this. Okay, let's have the shape of that. Okay, well, we have like 305 and 215. What we will do, um, what actually we will do in this case is uh, once we have the image, so let's take of like because it's just a reshape, so you need to matter of reshape, just take the reshape and reshape that into 302 and let's say 302 comma, because that's the shape it was being reshaped. So that's why I'm taking this and 215, because okay, now let's see. Yeah, so it's done. Now let's look into the length of the features. Obviously it's reduced because the grayscale. Now you can see the 302 into 215, and the number of features that was really there is 64,000, and that has been 65,000, that has been reduced to just 10,000 features. It's really cool and awesome. Now we can look into the hog image. That's really awesome. Now you can see that this is what actually the line looks like the rest all background of the background things is really not required, whereas wherever we have the change in direction or change in orientation, and those kind of things are really really required. That's what the hawk transformer is going to be explained about, and it's a really a very good feature extraction process. And this feature extraction process which really actually help us to extract the more features, and not only that, it will also reduce the dimensional reduction process. Okay, so in the next tutorial what we will do is that we'll create the pipeline and also the base model for this, and in scikit-learn, and that is going to be used in our pipeline model for the machine learning. Thank you very much. We'll continue in the next lecture. Hey everyone, welcome back. In the previous lecture, we have looked into our histogram-oriented gradients, so how to extract the features. Now what we will do, we will try to create a function, one base estimator, and that base estimator which actually do this operation. The first one is the grayscale, and second one is that it will calculate the hogs for the given image or given array. So now what we will do, we will try to import some estimators. So from sklearn dot base, import base estimator, and also import the transformer mixin. So these are the two functions we need to, or two objects we need to import. Now let's create a function, or let's create a class, and the name of the class that I just want to create here is the grayscale. It will actually do like, you know, RGB to gray. Okay, RGB to gray transform. I'll take this transform. Okay, that's what I'll take this, and inside that what I'll do, I'll just simply create an init double underscore init double underscore, and simply pass it. And the next step what I'll do is that here this is what the inheritance. I need to call the base estimator, and I also need to call the transformer mixin. So, and the next step we can also, that now we can able to do the exactly how we can able to do it for the things. So let's take the fit, and the fit the def dot fit, and it'll take, let's take this first one is self and x, and make sure, like, you know, of course we don't have x is not there with us, but still what you do is that you take a y and we just by default replace that with none. Okay, now what we need to do here is that we just do the return by itself. So return x. In the next step what we'll do is this transform. So now we're taking this transform and the self. Here what we are going to do is that we are going to give the x, and also we are going to give the y is equal to none. So these are the two steps we are going to given. And remember here the x is an image, and what I basically want to do in this process, I just want to I simply what I want to do in this process is that I just simply I just want to convert all the images. Let's say this could be an array, or it could be an array of 1,000 images or so on. So I need to do for each and every image, I need to do the transforming. So for that what I will do is that let me do one thing. Let me take this and just here just import from skimage dot io, just import skimage dot colors, and that's what I color is what I just want to import here. And now what I want to do here is that skimage dot color, and I need to do this RGB. What are the image I just want expecting is the RGB image is what they're expecting here. So let's say that now I just want to run in a loop. What I need to do here is that I just need to run a loop, let's say for x and capital X, and this is what I want to do here. So for x and capital X, so capital X consists of all the images, and for all the images what I need to do is that I basically need to work on it. So I can do this. I can also change something like this. I can do the map operations. Oh, map is not fine. Okay, anyway, I'll take this operation now, and this is what I'm going to return, and np dot array. That's it. So this is what basically I'm going to be written in this case. So that's it. So let me execute this. It's a self. Yeah. Okay, well, we're done with the rb I mean, like, you know, RGB to gray transform, trans. Okay, trans transform. Now let's do one thing. Let's take any image you want. Let's say I'm already having the images. Some extrain is what the images is there with me. So this is the extrain image, is a bunch of all the all the images are there, like, you know, bunch of all grays, I mean, color images are there, all are in RGB. I can quickly convert that into gray. You can see that xtrain.gray, all the images in the gray I can simply do by a fit transform. Fit, you need to fit, you need to take that values and transform it. Okay, fit transform. I can do this fit underscore transform, and what I can perform is this xtrain. That's it. So if I do this, so we have the data, white train, and fit parameters. I think I don't. This is the wrong. So it actually we need to return the self here. Okay, we need to return by itself. So that's the meaning of this. Now execute this and execute this, and what I will do is that I need to apply this form, like fit transform. The first thing I need to take this a thing. Let's say this is my RGB. RGB to gray. Okay, since it's an object, RGB to gray, and this is what my object. Okay, and let's call this object. Now let's do the fit transform here. Let's call this object, and done. Now what we have done is that we have simply converted each and every image into the grayscale. That's the coolest part what we can do here. So let me show you, like plt.aim show. This is my X train. Let me take the X train and one single image in the X train, and this is my grayscale. Let me take some random image. So let me take 10. Yeah, this is a grayscale. Now the sorry, this is the color image. Now the grayscale of that is the X train underscore gray is basically the grayscale of that. So what I'll do, I'll just plt.figure. I'm sorry, this is the plt.subplot, and I just want one row, two columns, and this, and let me do it same thing for this, and this time it is 2. Now that you can see, this is actually the grayscale, and you can set the CMAP is equal to gray. You can get that CMAP is equal to gray, and you can see that this is the grayscale image. So in a single step, basically this kind of transformation will basically help us to, in a single step, we can actually can able to create your own estimator. This is your own function, and that function can able to transform that function can able to transform all your values into the grayscale at a single step. So without any for loops, we can easily do this kind of functionalities, and this is kind of things will be really useful while doing the pipeline model. Thank you very much. We'll continue in the next lecture on calculating the Hawk transformer. Hey everyone, in the previous lecture we have seen how to create the base estimator in sklearn. So that base estimator, what it will do, it will convert that any image, any group of images into the grayscale. Now what we will do is that, now let me create one more transformer that is actually will calculate the hog of that. Okay, for group of arrays. So that could be the n number of arrays will be there for each and every, for all the arrays we will calculate this. So again we'll do the same thing. Let's create a class, and the name of the class I can use is like Hawk transformer, transformer. Okay, Hawk transformer is what I just want to use here, and let's take this init, df init underscore init underscore, and what I want to do is that I just want to pass the base estimator and also the transfer mixin. So those are all the inheritance, so that will actually support us. So next here I need to import some some few more things into this. So first, before doing that, let me make it as an empty, and again we'll come here and we'll try to fill it here. And the next one is that we need to have the fit is the function where we have the self and x, and we will have this y is equal to, of course we don't have the y is not there in the hog, but still we need to make it for this. And the next is return self. Just return the what are the self you have, just return it. Next what you need to do is that next is a transform, transform. Now we need to transform it. So we have like x, and also we have the y is also there. Just to make it, just put it as a empty, or a none. So we have the two things here. Remember, like, we need to transform. First thing is that I just want to create a function. So let me create a function called local, because I need to create a hawk transformer is also one of, because I need to dynamically change the values of the hawk based upon the inputs that user is going to be feed. So for that, let me create some local hawk, and in this local hog, and what I'm going to pass is that I'm just going to pass an image. Something image is what we need to pass it here. And so actually we just simple, like, we need to we'll take basically we'll take an image. Yeah, that's what we'll take it. And after that, inside this image, we will take this hawk transform. So let's import the scikit image. So import skimage dot feature. Okay, now take this, like, from skimage dot feature dot hawk. So we'll take the hawk transformer. Now let's take the hawk, hawk, and inside we need to write a few more things, like, on the image. So let me give some space. Now write down image is what the image I'll enter in the next image. And next what I'll do is the orientation. I need to get the orientation. So let's take its orientation, and this orientation probably I might get the input from here. So first one is self and the orientations. So let's take this orientations from here, and self dot orientations is equal to this. Okay, so that's what we can take, and by default you can make it as a 9, whatever. So whatever the default it was there, you can just make the by default it is a 9. And I'm taking the self dot orientation. Now I'll pass it into here. Next step, what is your interest is this pixels per cell. So pixels per cell is also this thing's also pixels per cell. Let's copy this pixels per cell, and I want this pixel per cell, so by default I'll take it as here. Now self dot pixels underscore per cell, just copy exactly the same thing, because I just don't want to make any mistakes here. So that's my pixels per cell, and just putting into the self here. Now pixels per cell is actually this self dot pixels per cell. Okay, yeah. Next, let me put comma, and the next important thing is the cells per block. Let's take the cells per block and also do the same thing exactly what we did here, and comma, cells per block, self dot cells per block is equal to this, and cells per block is equal to self dot this. So that's it. This is one of the few important parameters that actually required for me. So now it will going to return you the hog image, or this is hog features, not image. Hog features is what going to return by default. By default we are making the visualization is equal to false, so that's why it won't return any kind of things. That's it. So what we'll do, just return this hawk features, next step. So we got this hawk features, so this hawk features is going to be used here. So now write a loop here. Let's say for we have x, for x and capital X. So capital X is consist of all the grayscale images is being there, And for all the grayscale image, what I want to do here is that I need to do the local. I need to pass it to the local image. That's it. So this is what basically I need to apply. So that's my return. Okay, the return is basically what I'm trying to do is that I'm trying to take the local hog of x, and for x in x, and this is actually calculate all the his hog of this means hog is a histogram oriented gradients of that, and it's going to be written. So let me put it into the numpy array. All right, so that's how we can able to create our base estimator in the hog. Let's execute this. Execute it. Now let's take hog t, it's which is basically my hog transformer. Let me initialize this first. Execute it. Now let's test it. Let's test with this image, since I already did this part, already I converted all images into the grayscale. So let's take this grayscale and I just pass it into this, so that let's see, now x underscore train underscore, this is my hog. Will convert hog features. Basically it will get all the hog features into it, and the transformer hog t dot fit transform fit and transform it, because I need to do the first is I just want to do the fetch, and then I want to transform it. I need to pass the variables is my x underscore train underscore this. That's it. So it will take some time. What it's going to do is that it will taking each and every variable, and what are the hog variables I'm just going to pass it here. It is going to take this by default. I'm just giving you the same orientations, 9 pixels, 8 by 8, and so on. Okay, by default the orientations is 9 pixels per cell is 8,8, and cells per cell is 3,3. So I'm not changing anything, because that's also one of the hyperparameter, and those kind of hyperparameter I'm going to change in my pipeline model. Okay, so let's visualize it. So let's take the same thing, and let's try to visualize my function here. All right, so for this, so this is my 3. This is basically 3 because 1 row 3 columns, and this is also my gray, and this is the number 3. Okay, this time I'll increase the figure size. plt dot figure fixed size, it's 10,6. All right, so I'm having all the images. So this is what my hog. Oh, basically I can't visualize this, because this hog is basically consists of only the features. I'm sorry, I can't visualize at the moment. We can't visualize it. If at all you want to visualize it, you can create one more function of the hog, where you can or else we can do one thing. Let me make small changes at the moment. For example, let me take this image for this case sake only, and I just don't want to extend this case. What I will do, hog image is what this is what written. So I'll do the two returns here. One is the features, and second one is the hog image is what I'm going to get in this case. Now now what I'm going to take here is there are two variables are there. Basically I need to consider the two features, because it's going to return the hog features, and the hog image is also being returning. So I can take 0 probably. I can take the 0, which will be my features. This will be my features, h features. Okay, and next one is first one is h features, and second one is the img. So that's my image hog images, hogs, or let's say hog images. Okay, so that's what I can take it. This is what my one. And let me do one thing at the moment. Let me written only this because I just want to visualize at the moment. So just take this just for the fun and just want to visualize it. Oh, we got an error. It is too many values to unpack. I think let's do one thing. Let's me remove this because let's focus on. Let's take this now. Okay. I think let me put this comment, and what I'll do, I'll just remove this. Now execute it. Now execute it, and which is what too many values to unpack. Oh yeah, visualization. Sorry, visualize is equal to true. Yeah. So let's do it, and it will take some time. Just wait. I'm doing just only for the sake of visualizations, but this is not the reality we need to go. We want only the hawk features. This will take, if I do the visualizations, it will take much more time than usual. Generally it will take some, maybe if we take x minutes, and this will take probably some 2x or 3x minutes. All right, it is done. Now we can see that we got the hog image. Now let's take this xtrain.hog. This is a hog image for this particular one. And cool, you can see that this is what the hog transformation is going to do. This is my original image, and this is what the grayscale, and this is what the hog image. The hog is actually is really very interesting thing, which will able to do the feature extraction perfectly. Perfect feature extraction is really possible in the hog transformations. Anyway, what I'm doing here is that this kind of step, actually this is only just for the educational perspective. So I just don't want I really don't want these images, hog images, while doing my things. So let me re-back into this, whatever the things I have did. Just delete all these things and make the visualizations is equal to false. Just remove this, and also remove this, and just remove this. And hawk features is what we are going to get here. That's what, and just also remove the 0, and perfect. So just this is what actually we mean. This one is just only for the educational perspective, nothing more than that. Just only for the sake of education we took this. But I mean, what I'm saying, like, no, this is actually happening internally in the each and every iterations. Let's bring back to our old shape, and we will continue in our next lecture on training our machine learning model. Thank you very much. Hey everyone, welcome back. In the previous lecture, we have seen how to do the base estimators like Hawk transformer and also the grayscale. Now what we will do is that we will train a machine learning model. You can use what other machine learning you want. You can really use that. There is no it's not like that only this kind of machine learning model you need to use it. There's no such thing like that. You can use what other machine learning model. However, I'm going to use only one machine learning model, which is the stochastic gradient descent algorithm, which will really works for this kind of data. And also the support vector machines is also really work for this kind of data. Probably the tree-based algorithms may not work better like ensemble models like random forest, and XGBoost may not work for this, because this may not work for the image kind of data, because this is may not images. I mean, this is not a some, like, the text data which have certain kind of rules. There is no such kind of rules, because this is image data, and all that data is, like, spatial, like, put it in the spatially. So for such kind of data, I think you can go for, like, some logistic regression, k-nearest neighbor, and support vector machines, and also like stochastic gradient descent classifier, anything you want, you can use that. And in this case I'm using only the stochastic gradient descent algorithm. So now let's import the few libraries from sklearn dot linear model. I'm importing the stochastic gradient descent SGD classifier. So this is what SGD stands for, stochastic gradient descent. So I'm doing this. And the next one is that from sklearn dot model selection, also import CV uh, predict. We will say like um, we will also import this grid search because for hyperparameter tuning we really require this. Okay, so these two methods actually we required, and if at all you want, you can also take like cross validate and predict. This is also fine, and whatever you want you can take this, because but anyway the grid search method will anyway give the better answer. So I'll take only the grid search here at the moment. And also we'll also import the from sklearn, also take out the metrics, and that's already there, but still let me import sklearn dot metrics. Okay, so these are all the things I just really want to now execute it. Now let's take my model. So the model, oh, I just want to import one more thing here. That's the scalar from sklearn dot pre-processing. You can take the what are the scalar you want. The mostly used scalar is the standard scalar, which is the z-score. You can take this standard scalar. So now what I will do here is that let me call my model, and the model, which is what my SGD is what the model. So we'll look into that, like what is the model, and also what are the hyperparameters that was really there. And the loss, by default it is the hinge loss, will basically works like an SVM. So by default I'll take the hinge, and there is not much thing you need to do here because everything is been there. But in the cross validation and also in the grid search we will see more on that. At the moment let me take this loss is equal to hinge, and just put the what are the hyperparameters generally we going to be varied. And the next one is the probably the learning rate. What kind of learning rate is going to be used? So I can take the learning rate to let's say I will take there are a lot of learning rates out there. You can take like there is a logistic regression is there, and log stands for logistic regression. Oh, this is just scroll down, you can see the learning rates. Yeah, so learning rate, the first one is constant, second one is the optimal, and third one is the adaptive. Adaptive is sometimes really performs good, and because we'll start with the uh, lower learning rate, higher learning rate, and as the error comes down our learning rate is comes down. So and the next hyperparameter what we can see is the early stopping. Just make sure your early stopping is equal to true. Sometimes we can also make the early stopping is equal to false also. And that's it. So for adaptive, just a minute, for adaptive what we need to give is that we need to provide the initial ETA. Adaptive, yeah, we need to give the initial ETA 0. So the initial ETA 0 what we have is 0. Okay, so let me take the ETA 0 and just give some what are the learning rate you want. Let's say 0.4 or something. So this is what the learning rate, let's give it here. So this is what my SGD model, and I have initializers. Now, so first now let's define the pipeline here. Let's define the pipeline. The first step what we have having is that we are having xtrain and ytrain is there. So xtrain dot shape and ytrain dot shape. So xtrain dot shape and xtest dot shape is there. Okay, So this is what basically we have. The step number one, what we need to do is that for training, the step number one, basically we need to convert into grayscale. Okay, convert that into the grayscale. And the step number two, we need to extract the features. For the grayscale, we need to extract the features. Okay, and with those features, you can do, that's step number two. With that features, what we need to do is that we can do the normalization. We can do either standardization or normalization. So in this case, I'm using the z-score for the normalization, that is a standard scalar. And step number four is, once we get the normalization values, and that values we are going to go, we are going to pass to our machine learning model. Okay, that's this, and all the process is what actually comes under the pipeline. Now, so let's do one thing. Let's try to initialize all the values. So first thing is RGB to gray trans T, just T stands for transform, because I already have RGB to gray transform. Just initialize it. And the next one, next what we need to have is that next is a hog transformer. So let's initialize the hog. Let's say hog underscore t is what the transformer, and the scalar, or let's say, let me give the different name, like grayify, hogify, and scalify, something like this, some kind of thing, whatever you want, you can give it. And let's take the scalify into this. All right, so by default I'll take the what are the orientations and the pixels. By default I'll take all these things, and the grid, and in the grid search we'll try to find what are the best values we can able to find. We can find it. All right, now guys, now it's ready to try to do this. Now let's do our pipeline. So xtrain, the first step what we need to do is that we need to take this xtrain, and xtrain dot this is my gray, and take this grayify, or we need to execute this. Take this grayify dot fit transform, and you transform all your train data, xtrain. And the next step what we need to do is that take your um, grayify data, and then you hogify it. Okay, hogify dot fit transform, or fit transform your xtrain underscore gray. So you're transforming that. Next what you'll get is, for the train you'll get hog data. Basically you're getting the features here. Remember, make sure you convert that into this, so you should get the features here. So that thing you need to remember. And the next step is that we will normalize it. So we will do the scalify dot fit transform. It basically, what it will do is that it will try to calculate the z-score for the values, what are the we got. Okay, so let's take the scalify, and what we need to do, let's take this as transform underscore x hog. For all these hog values we are going to give it to this, and this is what my train, and that's my scale. So you calculate all the z-score for that, and this is, now you just pass it to your machine learning model. So now model dot fit. So what you're doing here, model dot fit, you are going this train x scale, and y is my y underscore train. That's it. So this is how the pipeline thing. In the grid search we will see how to do that. Let's execute it. Just wait for a few minutes. We need to do the grayscale, we need to do the hog transformation, and at the same time we need to do the scale it and everything. So it will take some time, so just be patient until it is being completed. Okay, that's it. So we have the list dropping is equal to true, and then learning rate, and everything is done. So now what we will do is that let's calculate our the score of that for our test data. So y underscore predict underscore test for the test data, how exactly it is being, let's check that. So model underscore std dot it's a predict, just want to predict for y x underscore test basically, and to do the test. But I can't directly apply the test here because everything you need to give it for the test in order to get this. So I need to hogify it, I need to transform it, I need to do many things here. All right, so what I want to do here is that I just want to just fit transform anyway, it doesn't matter. So next what we will do is that we need to convert into the hawk features for each and every value. We need to do that, and this scalify is just only our transform. Okay, now take this. See, remember this is only the transform because we already calculated the values here, and this is only the transform. We'll make the pipeline, that will be really easy. So now this test, and we got the hog, and this is my test hog. Okay, and this is the features. We will give that to the normalization, and finally we'll get the test scale. And this test scale you are going to give to the model, and this is your predict. Execute it. That's it. So this is how you can able to get your results and y underscore predict. So now you can able to get all your results, that is all the results whatever we have here. So this is how, like, you need to train and you need to predict your model. So in the next lecture we'll talk about the evaluation and also how to create the pipeline model, and we'll through the training, and we'll do the training with the grid search. So and finding out, like, best hyperparameters, like for what is the orientation, and what is the best hyperparameters for the losses, and that what kind of learning rate is really required. For all these things we'll calculate in the next lectures. Thank you very much. Hey guys, welcome back. In the previous lecture, we have seen how to train our stochastic gradient descent classifier, and also we applied, like, all the transformation methods like graying, hog, and scaling into that, and also we got the outputs. Now let's do one thing. Let's test our model accuracy and do all these things. Okay, let's do this, guys. So what we will do is that let's test our model. So what is our accuracy, precision, and the recall score of that? So for that, what I can do is that I can go for just the model evaluation, just get the classification report of that. So for that, let's take this SQL from sklearn dot metrics. It is what the classification report is, what I'm interested. So in this classification report, I already got the results for my test data. So let's give it for the test data. Now this is what my predicted values, and the true values is y underscore test. So that's it. This is how what it will return you the classification report CR. And let me convert that into pandas. So use this orientation dictionary equal to true, you can get the output in the pandas. In the dictionary you can convert that into the pandas. That is a really cool view. So we need our data frame of CR. So now execute it. So that's it. This is what you can able to get for each and every feature. Let's do dot transform capital T. Now you got, like, what is a score for each and every feature. So this is what the precision score for the bear, it is 27%, for the cat is 60%, for chicken it is 50%, and so on. The overall accuracy of the model is just 57%. Okay, the overall accuracy of the model is 57%. But for the multi-classification model, this is the multi-classification model, we are almost having the 20 classes. Approximately 60% is a really good score. So how to get this, like, we can have like kappa. So from metrics dot Cohen kappa. So this Cohen kappa will tell you, like, whether it is a good or bad, because uh, doing doing the ROC on that, it's highly not recommendable, because we don't have, like, because the multi-classification model, it's not recommendable. But kappa score will give you, like, whether it is good or bad. If the kappa score is more than 0.5, then it is an excellent, then it's a good model. If it is an 80%, then it is an excellent model, it's an outstanding model. Let's look into the kappa score for that. And y underscore, this is for test, and this is for predict. And the kappa score, it is 55, 0.55 approximately. It is a good model. Basically, the model, whatever you have built, is a good model. But okay, for accuracy, it's quite less. It's a fixed 60% is what the accuracy of the model. We can still improve the accuracy of the model, because there are a lot of hyperparameters that we need to evaluate. And the hyperparameters that it uses, I don't know what laws I need to use, and what kind of a learning rate I have to use, and should I go for the early stopping, and ETA is equal 0.1. What ETA is good? It is less ETA or more ETA? What ETA is really good? And that thing. And also in the Hawk transformer, we don't know, really do not check, like, what is the orientation, and what is a good orientation, what is the pixels per cell and cells per block. We really need to find it out. Okay, in the next lecture we'll talk about the um, grid search method for the hyperparameter tuning. Thank you very much. Hey everyone, welcome back. Now let's see how to create the pipeline model. And with this pipeline model, we apply all the grid search methods to it, because we don't know what is the hyperparameter that is really suits for the hog, and also we really don't know what is the hyperparameter suits for the model. So first, let's create the pipelining architecture, and for that we will apply the grid search. So what we'll do now, let's import from sklearn dot pipeline import pipeline. Okay, so this is the pipeline model I'm creating. So model underscore pipe, so that's my pipeline model, and that's going to equal to the pipeline. And let's give all the models here. What are the steps you want? Just give all the steps. The first step, what I'm going to do, just put it in a list. The first step, what I'm getting some gray, I'm getting some color images is there with me. And for that color images, which is an array, and for that what I need to do is that I need to do the gray. I need to convert into grayscale. Okay, that's what or grayify or grayscale. That's what the first step I just want to do. Okay, and what is the class name for that, and what is the model for that? And the model for that is RGB to gray transform is the model for that. That's it. Okay, this is the first one. And the second one, next, and the okay, this is here. Okay, and the next one, what we need to do is that we need to go for the Hawk transform. So in the Hawk transform, the model that I'm going to apply is the Hawk transformer. Is what the model, it's a class. Just initialize the class just as it is. And if at all you want to give what are the name you want, let's pass the value. So in this case, I'm just passing the orientation. Let's say this gives you 8, and the pixels per cell, it is it's a 10,10 is my pixels per cell, and the cells per block is 3, it's 3,3. Okay, this is what I need to pass. Just give it here, and the next step. And the next step, what I want to go do here is my model. Oh, scalar. I need to give the scaling part. So the scaling here is a standard scalar. So that's my standard scalar. And the next part is my model SGD model. stochastic gradient descent model is what I'm getting here, and the model name is stochastic gradient descent classifier. It's a class, and whatever you want, you can still specify. For example, you'll specify the same hyperparameters. Whatever we chosen there, let's say this is the same hyperparameter. I'll take the same hyperparameter. Anyway, we'll train it. We'll find it out the best hyperparameters that what going to be used, and done. That's it. So this is what my pipeline model. Now let's take my model underscore pipe. Now let's what I'll do, let's fit it. Let's train our model. So let's train our model with simple X train and Y train. So this X train and Y train, what we're trying to do is that the same step what we did. The first we'll calculate it will convert into gray, it'll convert into hog, it will convert into, like, it will scale it, and finally it will give it. So, and in the test size, we no need to do all such kind of things because everything is been there. So only we are trying to using that. That's it. So that's a really the one of the good thing. So now let's train it. Let's execute it, wait for a few minutes or seconds, depends upon your computer speed. Just wait until this process is being completed. All right, it's done. Now we can see my pipeline model has been trained successfully. Now I can predict. I can simply do the predict, and you want to get the probability of that. What I need to give, just need to give the test data, and let's give the test data and test it. So this is what my y underscore predict. Okay, y underscore predict dot underscore test is what my test data, and I can simply get that. No, because I don't want to pass it. I don't want to do again all these things. That's an advantage of the pipeline model. Everything is being there. Now what I'll do now is that let's evaluate your model. So metrics, some sklearn dot metrics dot classification report. What you want to get here is what my test, and y underscore predict underscore test is what I want to give, and orient dictionary output dictionary. Oh, sorry, output dect is equal to true. Okay, and that's my classification report, and pd we can queue directly here. So suppose pd dot data frame, and this dot capital T, just transposing our matrix. So that's print the cr, and this is what the classification report. Of course, oh, our accuracy has been improved, probably, like, by selecting, by I just only changed, like, 10,10. Maybe by selecting the other parameters, probably my accuracy might improve. In this case, my accuracy improves from almost some 56 55 percentage or 56 percentage to almost 59 percentage. Okay, anyway, so this is how, like, you need to create the pipeline model. In the next lecture, we will see how to find the best hyperparameters with the grid search. Thank you very much. We'll continue in the next lecture. Hey guys, welcome back. In the previous lecture, we have seen how to create the pipeline model. Now what we will do, we will try to find the best hyperparameter for the pipeline model. So let's do the grid search method. Grid search for hyperparameter tuning. Grid search method for hyperparameter tuning. Okay, so I'm just need to find out what are the best hyperparameters, and so that hyperparameter increases the model accuracy. Okay, so from sklearn dot model selection, let's import grid search. So grid search cross validation is what I'm going to use now. So let's take the grid search cross validation, and the first thing whatever we need to do is that we need to identify the best hyperparameters. So let me write down what are the hyperparameters we have, and the first thing what we need to do is that we need to give the estimator. Okay, my estimator is basically the pipeline model. So let me call this pipeline model and paste it here. And let me reset everything. Let me set to default, whatever is being available. So let's set it to default. And I really don't know, first thing, I really don't know what are the hyperparameters. So this is what my estimator or base estimator for this. I need to find out the hyperparameter. So execute it. The next step, what I want to do is that I need to write down the param grid, hyperparameter grid. Okay. So what this hyperparameter grid is about. In this hyperparameter grid, we will write down the parameters that we are going to tune. So let me take a dictionary, and inside a dictionary, let me take a list, and inside a list, let me create a dictionary here. And of course, we can create the multiple dictionaries, and each and every dictionary is a combination of the values. All right. So first thing, what we will do is that we will see the hyperparameters. Of course, the first in this there is no hyperparameters that I need to do, but I need to change the I need to calculate the few hyperparameters in the Hawk transformations. So first thing, I need to find out like what is the best orientation and pixels per cell, cells per block. So those things I really don't know. So for now, what we will do, let me write down the best hyperparameters. And remember, this is now how to call the hyperparameters is based upon this. Now you can see we have the Hawk transform is what the name of the estimator which I give, and underscore underscore, just use the two underscores here and followed by the parameter name. So parameter name is orientations. So this is what the parameter orientation, and this is my key, and followed by the values. We'll just write down like what are the orientations you really want to try it out. So I'll basically try it out some few variations, like I can try 7, I can try 8, I can try 9. If at all you want, you can try the more and more variations you want. So let me take 10 because 9 is already there. So let me take 10 or 8, 9, 10, 7, 8. It's up to you. You can take the you can also take the 7. And the next hyperparameter I need to really identify here is the pixels per cell. This is also the one of the hyperparameter I need to identify here. So what I want to write down here, it is Hawk under Hawk transform underscore pixel per cell. So pixel per cell is also I need to identify. By default it is 8 by 8. So let me take the values in a list, and the first one I'll take it is since 8 by 8 is already there, I'll take 7,7, and I can take 8,8, 8,8, 9,9, whatever you want, 8,8 and 9,9, and so on. So you can try what are the variations you want. You can simply try this, or you can also take the 10,10 is already there, and it's not much improved anyway. And let me take one more. Now Hawk transform underscore, what else is a hyperparameter you need to find? Cells per block. And just remember, the lower the cells per block is actually the best results what you can achieve. But we'll try to find a few more hyperparameters. Let's say I'll try 2,2. I can try 3,3, and that's enough. If at all you want, you can try more. And the next hyperparameter I need to identify is okay, I think it is done with the Hawk. And next one is the scale. There is nothing, and here is the big one is the SGD. A lot of hyperparameters are there. So SGD underscore, oh, this is underscore, and the first thing is loss. There are different varieties of loss or there. You can really find it out, the different varieties of losses. And however, I'll choose only the few losses here. So let me look into the losses that was available. You can see the by default is the hinge, and let me write down the hinge, and this hinge will basically works as a linear SVM. And next one is log. I think I don't require this log because it works just like the uh, basically it works just like a logistic regression. You can check the squared hinge. This will might works better, and perceptron like a neural network. And the next one is, of course, it's not a regression problem, so you not don't need to take this. And if at all you want, you can check the epsilon incentive and so on. At the moment I'll take only these three losses. And the next one is and the next hyperparameter I need to find out is learning rate. So good learning rate will get the good results. Okay, so sgd dot learning rate, by default it was optimal, so let me take the optimal. Okay, optimal. And next thing is let me look down the documentation of what are the learning rates are there. There is adaptive is there. You can take this adaptive, but remember the problem is that the adaptive will work. I mean, we need to select the ETA, and you can see that as long as the training keeps decreasing and so on, but in optimal there is no ETA 0. So but here estimator is 0 is there is here in optimal we don't need to select anything, but here we need to select it. So I need to also give the ETA here, but actually unnecessary. I'm calculating that optimal for different ETA. This will actually have a, I mean, those things are really not required for the optimal. So what I will do, let me take the one more hyperparameter. So this is enough for her. So this is the one parameters I'll try, because for ETA, because ETA, there is no ETA for the optimal, so that's why I can't put the like the adaptive here. So let me take one more parameter. So this is what the one more parameter. So hyperparameter. So this is any number of things you can select here. So now just put a comma and we get separate that. And here I'll take the optimal adaptive. All right. So I'm just taking the adaptive here. Now just select the ETA. So SGD underscore underscore is underscore underscore. There is also underscore underscore. Now learning rate. Okay, we have, let me stopping learning rate. This is ETA. Basically I need to select the ETA here, ETA 0. I'll take different ETAs here. Let's say by default it is 0, 0.001 and 0.01. Let's say, let me consider two ETAs and check what are the best hyperparameters. So there are different combinations out there, and in this all the different combinations I need to find out the best hyperparameters. All right, so our next step is that let we have grid search is there. Let's take this grid search model underscore grid and grid search CV. Now what we need to do is that first one need to give the estimator here. So just pass the estimator and comma param grid is what this param grid you need to pass it. So parameter grid is equal to parameter grid, and what else, right? Okay, next is scoring. So what kind of scoring we are interested? Basically I'm interested in the accuracy. So accuracy of the model I really interested. So find out the best model based upon the accuracy. And the number of jobs is equal to 1 at the moment. Just put the 1 because since we are working on the CPU, if you work on the GPU you just put the parallel operations of -1. Since I'm working on CPU, that too on my laptop, so it will take time to run all the models, but that is okay, but that's okay, at least 1 is good. Next is finally the cross validation. Let me run the cross validation for at least 3. If you want, you can increase that. 3 is fine. And verbose, just look into the how many models of your fitting, and just have a look into our models, like what is the score and how much time it is being set. We can look into that by just putting verbose is equal to 2. So that's it. So we have all the parameters already, and base estimator is ready. And let's try to find out the best hyperparameter which increases our accuracy from from 62 to, let's see what accuracy you're going to get now. So let's execute. And now we need to fit our model with the data, train data and the test data. So what we will do is that model.predict, so model.fit, so x train comma y train. Now let's train our model for almost 486 models is what we are going to fit, and 162 candidates. So probably it might take a while, maybe 30 to 40 minutes time it might take a time. So please be patient until this process has been completed. Do not stop the process. It'll take a really long time. 30 to 40 minutes is what the expected, and please be patient until all the process has been completed. Thank you very much. We'll continue in the next lecture. Hey guys, welcome back. So I finished the training of my best hyperparameter tuning. It took almost for me 49 minutes, so nearly 50 minutes it took nearly for me to fit all the 486 models. So this is what, now let's look into the best hyperparameters, and out of this, so let's look into that, guys. So then this is my model, and the best hyperparameters, you can see the what is the best estimator, best index, so best parameters that was found. And you can see that best hyperparameter it was found is the hawk cell, it's 2 by 2, and the orientation is 10, and hawk transform pixels per cell is 8,8, and SGD learning rate is optimal, and the SGD loss is hinge. So this is what the best hyperparameters that I got. You can also got the different hyperparameter, doesn't matter. So ultimately what it is trying to do is that it's trying to identifying the best hyperparameter for you. So now let's take this score of that. What is the best score we got? And so this is the best score, and oh, it's pretty good. Like it's we got the best score is nearly 73%. The previous best was 62% is what the accuracy of the model. Now you can see with this parameter if we choose, and we get the 73% is what the accuracy of the model. It's really good. For 20 classes the accuracy of the model is 73. So really awesome. And you can also let's predict the model. So what we will do is that let's save it. So model underscore best is equal to model grade dot estimate best estimator. Okay, so what I'm trying to do in this case is that I'm just I'm just loading into my model underscore best parameter. So this is what the model underscore best, and this on all the hyper parameters that I'm going into load into this. Okay, and now what we can do is that you can also look into the get parameters of this. Of course we already got the what are the parameters, but here you can look into that what are the best parameters which we used is this. Oh, sorry, yeah, which we used is this is the best hyperparameters that we have been used. All right, anyway, so what we are going to do is that let's trying to predict the values from this with our test data. So model underscore best dot predict, and it is what with respect to my test data. And let's look into all the precision recall score of our model. So for that, let's say CR is equal to we already got this from sklearn dot metrics dot it is a classification report, and what I want here is that y underscore test and y underscore predict, and output text is equal to true. That's it. So next step is that pd dot data frame of cr, So it will try to give you the best parameters. Now you can see, guys, so the accuracy of the with respect to test data is good. It's a 74, almost 75. So 75% is what the accuracy with respect to my test data, and this is what the precision for bear, for cat, and for chicken, and so on. It's really good right now. It's a really good prediction for almost all the classes, and the few for the human it's 95%, and the support indicators how many samples that is being tested. And we tested for the natural. For the natural we have only one sample that was there, and it's okay, there are no predictions as being done for the natural, but overall if you see, like, your model perform really good. Now I think it's a good model, so we got the hyperparameters. So finally what we will do, we will save our pipeline model. So as we did, we already imported the pickle. So let's save our model. So pickle dot dump. So we are saving a model, and the object that I'm going to save is the model underscore best, and the file name is I'm just saving with the file name with the name of what are the name you want, DSA, and this is my uh, model best parameter dot pickle. Okay, you can save with any extension or format you want, and the mode I want to save here is write in bytes and execute. That's it, guys. Now you can see that we have saved our model successfully. As you can see, here is a DSA underscore model underscore best dot pickle is what the data that we have saved successfully. Hey everyone, welcome back. So in this lecture, what we will do is that we will try to create the pipeline model, and this pipeline model, which is basically used for the deployment. So what we're trying to do is that we created one pipeline model, and that pipeline model is used to find out the best hyperparameters. But now what we're trying to do is that we are trying to create a pipeline model from end to end. So we have the input of image, and we need to do some certain kind of transformations. And once we do the certain kind of transformations, that we need to pass to our machine learning model. And finally, we will get the outputs. Okay. So for example, I'm having a certain images with me. And if I pass those images, for example, so the point here is that we train the model with 80 by 80 pixel. So it need not be necessary that what are the images we have, it's always 80 by 80. It could be of any size. For example, let me consider this image eagle. So this is the eagle image, and so this is, you can see this is having the different dimensions. It's need not to be 80 by 80. For example, let me open this eagle image. So this is what the eagle image I'm having with me, and you can look into the properties of that. There you can see the properties here. The dimensions is 868 and 960. It indicates that width is 868 and height is 960. But we train our model with 80 by 80. So what are the inputs you need to pass? That input should be of 80 by 80. So that things only work. So in order to work in this case, we need to do certain kinds of transformations. Okay. So that is what we're trying to make it now. So that's what the make transformation. So here I list down, like, the what are the optimal parameters, and these optimal parameters we found out using the grid search method. Means, like, the hogs is 2 by 2, and the orientation it is 10 pixels per cell is 8 by 8, and the learning rate is optimal, and the loss is hint. All right, so let's go to the model. So this is the model we are trying to repeat now. So with the best parameters, we are trying to repeat this model. So goal of that is that just take the transformation. So this will work for n number of images, and this will work for n number of images. And we don't know what is the standard deviation and the mean of that. That need to be calculated. And again, for the best hyperparameters, we build the model. All right. So let's remove all these things, and let's put it in a way. The first step one is basically we have just put all those things. The step number one, okay, the step number one, what we have here is that we need to do the RGB transformations. And the next step, what we need to do is that we need to calculate the orientations. And so what is the orientations here? The best orientations is 10, and the pixels per cell is 8,8 is what the best pixels per cell, 8,8, and the cells per block is 2. Cells per block is 2,2. So okay, so this will become one pipeline, and I'll calculate this separately. And finally, I also need to calculate this separately. So why we are doing this is because we need to deploy our model. Just thinking the deployment perspective. For the deployment perspective, uh, we are trying to build a model for the deployment perspective, not for the image transformation perspective. Okay, so that's the reason we're trying to do here. So first step is that, like, this, let's make these two as one pipeline, and once we get the output from this, and that output will pass it to our machine learning models. Okay, I mean to our machine learning model, and this is my start applying some kind of transformations. All right, so the first step what we do is that let's import the make pipeline from sklearn dot pipeline, import make pipeline. So let's import this make pipeline, and this is what my pipeline one, and this is what my pipeline one is, the make pipeline. And first thing what we need to do is that we need to pass that to our RGB transformations, and then to our hawk transformer. This is what we need to do, hawk transformers, right? And this is what the pipeline one. So let's execute that my pipeline one now. All right, so our next step is going to be our um, standard scaler. What I need to do here is that I need to calculate the standard scaler here. So this is what the value, and this is what the transformed value here. Okay, so since what I'm having is that in the pipeline model, I'm getting the feature vectors from the hawk transformations, and that value that I just want to save into my transform value. Okay, or else first one, this is what the feature vectors, and what we will do is that the step number one is the fit transform all my trained data. Correct. So we get what we're trying to do is that we're trying to transfer all the trained data. In the next step, what we will do is that we have to apply the standard scaler. Okay, the standard scaler, let me put it as a scaler, is a standard scaler is what I just want to apply here. And now let's do the fit transform here, fit underscore transform features vector. So, and this is what my transformed the transformed values, or this is what my transformed extrain. Okay, and we got the transformed extrain executed. All right, now once I have the transformed, let me make it transform. Once I have the transformed train data, and what I'll do is that let me do the SGD classifier. So take this SGD classifier and fit the by best hyperparameters. So first one is the learning rate is optimal, and loss is hint. All right, so that's what the loss we have. And you can also set some bunch of parameters, like you can set the, since the penalty factor is lasso, in order to avoid the overfitting of the model. This is because we can increase the value of alpha to increase the overfitting of alpha. Let's say I'll put this alpha is equal to 0.01 just to avoid the overfitting. If there are any overfitting is there, just will reduce that. And also I'll use this at least stopping equal to true to avoid the overfitting of the model. Okay, so this is what the model that I'm going to use now. Execute it. So what I'll do here, let me train my model. So model.fit, it is what the, it is a transformed x comma y underscore train. Oh, we got an error. It's found that um, inconsistent number of samples. All right, let's check the shape of that. Okay, the shape is 412. I think we missed somewhere. So let me do this again. Let me do this. Just compute it again. Do this again. Do this again. Maybe there is some kind of. I just change the spelling. Doesn't matter. Yeah. Okay. Just because of change in spelling, I think it was change something. Anyway, this is what the model which we train. And now let's test our model. Let's evaluate our model. Okay. So if we evaluate your model, this is my y underscore predict underscore test is model dot predict. What is that? We can't directly pass or extract data. We need to do certain kind of transformations. So that's what we will do. So first one, we will take the pipeline. So this is what the pipeline one. So you need to take the pipeline dot fit transform. So once you fit transform your pipeline model, and you'll get the feature vector. Basically, what you'll get here is that you'll get the feature vector. So x train, and you'll get the feature vector. Now, once we got the feature vector here, and the next step, what we need to do here is that we need to scale it. So let's copy and paste it. Remember, this is what the transform x, but we already fit the value, so we don't want to fit it again. If you fit, you lose entire information. So don't fit it, just put only the transform. And once we have this transform and we got the transform x, and that need to pass it to our model. That's it. So we execute this. Just wait for a few seconds. Done. So we got our results of y test, and let's look into our classification report. For that, let's go to the metrics dot classification report. It is y predict comma y underscore sorry, this is the y test true value because that's into pass a true value, and this is the y predict test, and output deck is equal to true. That's it. So now what we will do is that this is what my classification report, convert that into pandas data frame. That's just for the nice view and CR. All right, we found inconsistencies. I predict test. Sorry, this is test data. Basically just doing for the test data. Execute it and execute it. So that's it. Oh, anyway, let me do the transform. I think I need to do at the end transform here. Cool. So that's it. Now we can see, yes, there you can see here your model has improved the accuracy here. It's been improved from probably some 72 or 74. From there it's improved from this, so not much improvement. So why we did this kind of operation? We did this because in order we need to avoid the overfitting of the model. In order to avoid the overfitting of the model, so we added like alpha. Just play with the different values of alpha, and you that will avoid the overfit on your model. So since we avoid the overfit and the accuracy has been improved. All right, so this is what the we need to do. This is what we had, and the important thing, the important observations, what we need to do here is that we need to save our model. The first thing is that this is what we need to save, and we also need to save the scalar. These two values we need to save, because these two values that or uh, these two classes or these two objects that we are going to use in our model or for the Flask app. Okay, so what we will do is that we will try to what we will do is that we'll try to save our results. So save models for Flask app. For the Flask app, this is what we are going to use here. So let's save it. So how to save that? So first thing, I need to do this model, pickle dot dump. And what is the object that I want to save here is that the object I want to save is model. And a file that I want to just the name of the file I just want to make it is this is my DSA. And since I just want to do the image classification, this is my image classification. And underscore sgd, since it is a stochastic gradient dot pickle. So that's what pickle, that's what I want to save first. And just write in bytes, execute it. Done. We have saved this successfully. Also, we also need to save our transformer. This is the scalar is also we need to save, because this pipeline model anyway we can make it. So scalar also we need to save it. So for that, what we need to do is that this time it is a scalar, and DSA, this is what my scalar. And just so this is these two models I just want to save and write in bytes. That's it. So we have the two models, DSA image classification, and we have one more model, DSA scalar pickle. Okay, so in the next part what we will see is that we will see we'll take an image, and with that image what we will do is that we will get the output uh, with this one. What are the models we have saved, and we'll take a new notebook. In the new notebook we will see, like, what are the models we have, or what are the models, how to load all the models, and that is going to be used in our Flask app. Okay, we'll see in the next lecture on that, on making the pipeline model, more on this. Thank you very much. Hey everyone, welcome back. In the previous lecture, we have seen saving our data, and also we have heard the overfitting, and we also see how to save our models. Now, what we will do, let's take a new notebook Python 3, and in this new notebook Python 3, we will make the pipeline model, and that is what basically required. That is going to be used in the Flask app. What are the app we are going to create, the web apps? So what are we are returning here, and this is what going to be used there. So the three is, let's make pipeline. All right. So this first step, what we need to do is that we need to import all the required libraries for that. So the required libraries is, the first one is NumPy as NP. We want pandas as PD. That's also is very much required. And we also require the SciPy, scientific Python, because we might calculate the z-scores, and also we'll calculate the softmax function out of this. So just in order to calculate the probability of the output what you get. So we'll see that. And the next thing what we require is that we require the sklearn, and we also required the from import from sklearn dot pipeline import make pipeline. So this is also required. And what else required? So we also required sklearn, we required OS, and these two libraries this is the libraries required. And now let's coming to our skimage. So for skimage, what we require from import skimage, and import skimage dot color, import skimage dot we don't require, we require the transform here, and import skimage dot feature. So this is what very much required. So if anything required, we'll put on all these things. So import OS transform DRANS transform. All right, so you get just a simple warning, just ignore all the warnings here, so it doesn't matter. Now what we need to do is that this is what we had. So I request you just go app and copy. We already did such kind of thing, so we just copy this RGB class transformer. We require this, just copy this. And we also require the hawk transform class, this is also required. So just copy this, and also please copy these two. Now on the top of this, just import from sklearn dot base, import base estimator, and also transformer mixin. Okay, these two values is very much required. So remember, so we have this feature should be there, and this is also required now, so import it. All right, so what we did is that we just imported. Now what we'll do, we discuss about this previous section on this. So we will take, what we'll do, we'll read this image, and we apply to our pipeline model. Okay, so for that, first thing what we need to do is that we need to make our pipeline model ready. So pipeline model. So what is the pipeline model? So make sure we have the pipeline model is ready. So for that, the step number one, what we need to do is that we need to get the RGB transform of this. Okay, and we need to do the hog transform of this, and so on. Anyway, so first what we will do, let's import the model. Let's import the image. So image is equal to, first let's load the image. We require the skimage.io. Let's also import that skimage.io. And now skimage.io.image read, and read the image. It's a eagle.jpg. So that's what my image. So in order to visualize it, also import matplotlib, import matplotlib.pyplot as plt. Just import that, and also percentile matplotlib inline. So this is just for the visualizations, but anyway, this is not at all used for it's not used in the deploying your Flask app. Anyway, just visualize it. So plt.imshow of image. So that's it. This is what the image, what we have read. Done. So what is the next step? The next step, what we need to do here is that we need to pass this image because we train our model in 80 with 80 by 80. So for that case, what we need to do is that we need to transform our data, transform image into 80 by 80. So how we transform the image? The question is that how we transform the image. So from skimage.transform, we have resize is there. So we just use this resize operation, and using this resize operation, we can resize our image to any shape you want. So take this image and resize that into 80, 80. So that's what my image I want. So image underscore transform. This is I just transform, or image underscore resize. The first step I did is that resize. All right. So what happens is that if I do this, I got an image. So what I did here is that I resize the image. But the problem in doing the resize is this. Whenever you're trying to resize, what happens is that my data or the resize will try to normalize your information. So because you are normalizing your information and you lose it, because thing is that we train the image with the 8-bit image, means all the images that was there in the values in the range of 0 to 255. So for that we need to rescale it again. So image underscore scale. So for that, what I'll do, I just multiply this with 255. The reason why I'm multiplying is that I train the image with an 8-bit array. Okay, no, I just train the into 8-bit array. I just want to make sure, like, what are the array I'm getting is an 8-bit, so not the float values. So that's why I'm again multiplying that into 0 to 255. And if I resize that into 0 to 255, and this is what actually I'm getting. So it's actually messed up. So I actually messed up my information. So what happened here? What basically happens here? So the basic information, what happens here is that the reason why we got this is, like, we got certain float values. So float values actually messed up your all the information here. So that's the reason Anyway, what we have to do is that we have to transform data into 8-bit. Okay, so image underscore transform, and I just want to do the resize operation, or I just want to change the data type or typecast it as type, and it is np dot u int 8. This is means that, like, this is what my 8-bit array. Now we can check that we able to bring back into our original shape. So what we did is that we actually scaling up our image into the 80 by 80, into the 80 by 80. At the same time, I'm bringing the data into the 8-bit, because this is what the data I train it. This is the data I train to my the model. Okay, that's the reason we have to bring in the same format. Now your model is ready. Now your data is ready. The next step, what we need to do is that we need to pass it to our RGB to grayscale. This is what we need to do. So what we need to do here is that we need to pass our data to this. All right. So for this, what I'll do, I will first step I'll do the RGB to gray. Anyway, I think I to be precise, I just really don't want this. This hawk transformations and all these things is to really don't want for me to transform it. I can simply take this sk image dot colors. I can do that. Okay, so let me do that RGB to gray. But if you really want that, you can also take this RGB to D transform and apply the fit transform. That will also really work. But in my case, I really don't want that. Now anyway, so the next step, what I'm doing here is that I'm just converting into RGB to gray. So for that, I'll use skimage dot color dot RGB to gray. And what this is trying to do is that it's trying to convert that into any array into RGB to gray. So this is my array, and that's going to convert into RGB to gray, and this is what my gray image is. Done. In the next step, what I'll do is that I'll calculate the hawk features. So just calculating the gradients of this. So this is my features. For that, I can use skimage dot features. This is skimage dot features dot we have many features out there. So we have the hawk. What we basically interested is that we have the hawk. Now just choose as best hyperparameters. In the previous lecture, we already saw the best hyperparameters. Scroll down there, you can see the best hyperparameters is orientation is 10, pixels per cell is 8, and cells per block is 2. So make sure you just make sure all these things. So I'll just mention that, like, orientation is 8, orientation is 10, and pixels per cell is 8. Let me check that. It's 8, and cells per block is 2,2. Okay, now we need to pass the grayscale image to this. So grayscale image, so now you just pass all the information whatever you had, and you get all the feature vector. This is my feature vector. All right, done. So now for this feature vector, what we need to do is that I need to pass my model. So this is what I'm getting the image. So this is up to here. This is just, let me execute up to here. So now we got the feature vector here. So this is what the feature vectors that I'm having now. So for this feature vectors, I need to scale it using the standard scaler. If you remember, we already had the model for that. In the previous lecture, we have saved this saved this standard scaler and also classification model. So now let's load the model here. So what we'll do, let's load the model. Okay, the model that's going to be load here is pickle. I need to import the pickle. Did I import? No. So I just need to import the pickle here. Import pickle, and pickle dot, the first thing I need to load the pickle, and open the image, open the file name, and the name of the file name is DSA underscore. Just take the exactly file name. This is what the file name of my model. Take this file name and DSA this model dot pickle and read in RB. And similarly, take the scalar is the pickle dot load, and you need to open that model. And this time the model name is DSA pickle is what the name of the model. DSA pickle. I need to read in RB. So that's it. So we have load our pickle successfully. All right. So you can see all the parameters that was there, like this is you can get parameters. You can see what are the parameters that you have trained here. There you can see the alpha is 0.01, early stopping is true, and the learning rate is optimal, loss is change, and so on. So we have this information now. Anyway, so now what we are trying to do here is that we already have the feature vector. That feature vector we need to scale it. So this is what my scale x, and take the scalar dot transform. You have to do the transform here. Transform your feature vector. Once we got the feature vector in the scale, now you need to pass that to our model. So model dot predict. What do you need to do? Model dot predict, and predict is what predict of the scalar. Okay, scale x. So that's it. This is what the result you'll get it. This is my result. Only one result since we have passed model. So we got some array. This says it's yeah. Okay, the problem is that this, let's look into the shape of that. Yeah, the shape here is that, like, it is 3240. Whenever you're doing some kind of transformation, it should be of proper shape. The shape should be it should be of the proper shape. So that why what we will do is that we will resize. What we will do, we will resize, oh, sorry, we will reshape that into -1, 1 comma -1. So what it 1 comma -1 will do, basically we should reshaping that into the row matrix. So one row and 3240 vector. So that's why we are doing this, and let's calculate. Done. So we have done our results. On now let's see, this is calculating, it is an eagle. Obviously I load the model, I load the value is eagle, and it is giving me the eagle. That's it. This is how, we are able to get from the data what are the shape of the data, doesn't matter. So what we will do, we need to transform it, and we need to rescale it, and get the feature out of this and pass it to our machine learning model. So with this, what we can get is that we can get the eagle. Calculating the probability. Now thing is that, what is the probability that it is going to be eagle? So in the many models that was there is a predict prob A is there, but the problem in this loss function, what are the loss function we have used? The loss function hinge. In the loss function hinge, we don't have the prob A. So suppose if we give the scale x, it will throw an error saying like there is the probability estimates not available for the loss hinge. Of course, because the algorithm itself says that we never use this probability to find out the whether it is an eagle or what other class it is. Okay, for that what we need to do is that there is a powerful technique is there called decision function. We use this decision function, and this decision function will actually calculate the confidence scores. This basically calculate the confidence score for each and every class. So now we can take this, now we can calculate the decision, and this is what the DCISI, this is the decision value, and calculate the decision value here, and you can get the decision value for each and every class. So there are 20 classes out there. For each and every class, it gives a decision function. Whichever value is highest, and that's give you the particular information. Okay, so now what are these classes here? What is this? What is this? We already know that this is a, it will arrange in alphabetical order. But anyway, we have the model dot classes is there. Now we can get this. So what happens is that, and the first class is bear. This is the bear, and for bear the confidence score is minus 167. Basically, it calculate the distance. Okay, for cat it is minus 210 and so on. So we have the decision function for the respective classes here. In order to better understand, what we will do is that we'll try to visualize it. Visualizations is a really good thing to understand betterly. Okay, let's look in the shape of that, because anyway we can't get this information, because for visualization it should be the flatten. So let's flatten it, and if you flatten it you will get, like, just the shape is just neither a row matrix neither a column matrix. So we'll get some 20. Okay, we have the classes here. This is what my labels, and this is what my uh, decision value. Okay, so we have the labels and we have the decision value. So what we will do, we will visualize it our results so that you can see whichever is important. So plt dot, let's take the bar plot, and for this bar plot the x values is the decision value and labels is what my y. So oh, sorry, this is I just messed up. This is my labels, x-axis is my labels and y-axis is the decision value. Sorry. Yes, now you see, now what happens is that we got, so whichever value is low, whichever value is highest, since this all the values are the negative, so that's why I got. So instead what we can do, we can put that bar edge, that will be the nice value which we got. Okay, now we can see here, this is really nice to understand. Instead of taking the bar, we can take the bar hedge. It is easy for us to understand. And let me put that, like, plt dot create to get much more visualizations. Now we can see which our lowest, and that is going to be the eagle and the duck. Eagle and the duck are the two lowest values, and followed by probably the pigeon and chicken. So it's a good thing, like, the probability that is going to be given is everything is our birds are having the highest probability that is going to be good. And so our model is performing really well here. Anyway, so we got the decision values here. So what we need to do is that let's compute the probability out of this. In order to compute the probability, the first step what we need to do is that we need to calculate the z-score for each and every value. Okay, we need to calculate the step for computing probability, calculate z-score. So z-score, we can use a scipy dot I can take the stat dot z-score. We can do that. So you can see, or you can simply do take the mean and standard deviation of that. You can simply do the z-score, but anyway the function is already there, so I'll reduce my effort here. So take the decision value, and I'm getting the z-score here. So this and all the z-score for each and every value. And for this z-score, you can get the probability values by applying that to the softmax activation function. So for that, let's apply to the scipy dot special dot softmax. So what the softmax will give you, or softmax will give you all the values in the between the 0 to 1 scale, and the sum of all the values is equal to 1. So that's a very good thing in the softmax, and just pass the z values and calculate the probability values, and that's it. So we can see this is what the probability for each and every class. So let me reproduce our graph again. And what happens is that so this is my probability value. So prob value, this should be in my y-axis, and this is my labels and prob values. So that's it. Okay, this is now we can see that eagle has the highest probability, almost 17.5 is the probability, and the next one is the duck is having the good probability, and so on. So suppose, let's say, if at all you want to display the top 5 probability values, if at all you want to display the top 5 probability values, let's take this probabilities And in this, I want to get the print the top. I just want top 5 probability. Let's say top 5 probability values. Suppose if at all you want top 5 probabilities, then you can do the awk sort. And if you do the awk sort, it will return you the index position of the top 5, the index 19th index position, and followed by 10th index position. And I think maybe this is not in order. Probably we can rearrange it, probably, like, because 19 is basically something like probably wolf or something, whatever. Because wolf, this is 0 and this is 19 wolf, so probably I need to reverse it. So how to reverse it? Probably colon -1. I can reverse it. Okay, now you can see this is my top 5 pick. My top 5, the top 5 is if seventh position, and so on. So this is the top 5 prob index. Okay, so we got the top 5 probability index. Now take this top 5 probability index and pass it to our labels. So where's my labels? This is my labels. So in my labels, what I'll do, I'll pass it this top 5 probability index into this. And yeah, so I think I'm getting everything. Okay, this is the top 5. Oh yeah, okay, anyway, I'm getting everything here. So what I'll do, I'll take only 5. Maybe I'll take only 5, colon 5. Just take the colon 5, only the top 5 values. Now I just pass the top 5 values to this. Now you can see we got the top 5 values here. So this and all the top 5 values. So I'll take, like, this is my top 5 top labels, and the corresponding probabilities, top probabilities, take this probability values, and in that probability values just take the index of this. So now you can able to get, like, the top values. So this is the top probabilities for the corresponding labels. So for eagle, this is what, for duck this is, and so on. All right, so this is how, like, you can really make up, like, what is a top pick and so on. And in simple, what we can do is that we can, if at all you can able to put it in dictionaries, and that will be really great, like, for the machine learning model, or for the Flask app. Dictionaries are the really good thing, good output, so that we can able to produce in the output 6. So for that, what I will do is that um, so I just want to convert this. I have an array here, I have one more array here. I just basically I just want to convert that into a dictionary. So for that, what I'll do is that, like, top dict, this is my top dict, take my dict. Now what I'll do here is that for a key comma value in zip off, this is what my first one is key, take the top label and the top probability, and now print key comma value. So we got key and the value for each and every case. All right, so now what I want to get here is that I just want to, but here you can see there are so much of values out there, all the float values. I really don't want these things. I just really want to put it into the 2 decimal points. In order to do that, you can take, like, np dot round. You can take the np dot round off to how many decimal points you want. You can simply ask it. So this is the value, round off to 2 decimal points. I can simply do this. Okay. All right, so now everything is ready. So let's take this dictionary and top dict dot update. Now this is my key and this is my value. So what I can do here is that key, this is my key, and this is my corresponding value here. Execute it. So this is my top dictionary. So what we did is that we created the eagle, like, we created the output in the top form. So in short, what I did is that we passes some input to our model, and with some kind of transformations, extracted the features, pass it to our machine learning model, and we got some decision function. And that decision function, with the help of this decision function, we calculate the probability of this each and every decision function. And based upon this probability of the decision function, we given you the top 5 pick of this. So now we can see the eagle is first, followed by duck, followed by chicken, and followed by pigeon, panda, and so on. All right, so this is how that you are going to uh, get the values of the top picks. So suppose if you want 3 decimal points, you can also take the 3 decimal points. This is the 3 decimal point values, so it doesn't matter. So everything is seems to be really good. All right, so what we will do in the next lecture, we will put all together in one function, and we will complete with the making a pipeline model. So we'll continue in the next lecture more on that. Thank you very much. Hey everyone, welcome back. In the previous lecture, we have seen a lot of things on calculating the probabilities and so on. So what we will do now is that we will put all together. So what we'll do is that we will put all together and put everything in a function called pipeline model. So input for that is could be an image in an array, and for the image in an array, the expected output should be this is my return. The expected output could be the top tip. Okay, so that's what I'm expected. So what are the input array, or you can simply give the path of this. That's really cool, right? Now if you give simply the path of that, and the expected output should be this. Okay, so that's what we are going to do now. So what we will do, let's copy all these things. So first step is that, like, we need to read that image. So copy this. So we need to read everything and paste it here. So just make sure you put some indentations, otherwise you throw in an error. And after that, we need to do the scaling. So what we need to do is we need to do the scaling and build the machine learning model. So for that, so this is what the scaling we have, and take the scaling and get the results here. Okay, so we have the scaling and we need to get the results here. All right, so in this case, the scalar is also one of the input. Scalar is an input because because that is going to be loaded from the pickle, and even the model is also an input. So even the model is also input, and the scaling is also input. So I'll put, like, scalar transform just for to clear, and the model, this is what my model SGD. Just why I'm doing this is, like, make sure we don't want to forget this model underscore SGD. All right, so these two things I just want to pass it. And once I got these two, next what I'm doing here is that I'm taking the decision function. Okay, I'm just calculating my decision function here. So where I got here, you can see I got the decision value here. So once I got the decision values, and check this. So once I got the decision value here, and for next, what I do here is that I need to do the flatten here. I can simply write the flattening here. And once I got the decision values, and the next one is the labels. In labels, I can get from the model SGD. This is the model SGD dot classes is what we can get the labels here. And after that, we need to calculate the z-score for that. So after that, what we need to do is that we need to calculate the z-score for that. Z-score, and this is where this is my z-score and all the probability. So after that, what we have to do is that we need to calculate z-score. For that z-score, I need to give the probability. For that, basically getting the confidence score out of this. So this is basically gives the confidence. Okay, confidence information. All right, so once I got this confidence information, in the next step, what we need to do is that taking out the top 5 picks. Okay, and this is just gives the information. So this is my top 5. So this will give you the index position, and once you got the index position, you take the values of the top 5 index values of the labels, and also top 5 index values of the probability. So basically we are going to take this labels here. You can see the labels, and we are also going to take the probability values from here. And once we got the labels and the probability values, we need to put it down in a dictionary. Put in dictionary. Okay, dictionary is the most convenient format, and that format will be useful whenever you are using some kind of APIs. You want to return some kind of APIs, that will be really useful. So what we did is that we created the dictionaries and we got the top 5 values. So this is what the top 5, and what we got is that we got our entire model ready. Execute it. So I think in this case I need to give the, instead of eagle, I need to give the path of this. All right, so now what I'll do, let me take the pipeline model, and this is what my pipeline model, and the expected values is the path, and the path of that is the eagle. Just give the eagle is not the path, and the scalar transform, I need to give is the scalar, and the model SGD is what the model already developed the model, and this is what the model. So this is what my res is, my results, and res, let's print out this. So it will calculate everything. What I'm doing, it's doing all the resize, reshape, and transforming, and finally giving you the results. All right, so this is what the most important thing. We use this in the Flask app to get all information. So that's it, guys. So this is how we make the pipeline model. In the next module, what we'll see, we will create our Flask app. So in the Flask app, we will also see how to integrate our machine learning model, and then we'll finally see the deploying of Flask app in the any cloud platform. Thank you very much. We'll continue in the next module.